Hello and welcome. If you're here, you've come to the right place to drift off into deep, restful sleep. Over the next few hours, we're going to journey together into the deep ocean, one of the most mysterious, peaceful, and awe-inspiring places on Earth. There's no need to focus too hard on what I'm saying. Just let the words wash over you like gentle waves. Let your breathing slow. Let your body sink into comfort. We'll explore fascinating facts about the ocean's depths. But there's no test, no need to remember anything. This is simply a quiet space for you to relax. The ocean has always held a special place in the human imagination. When we think of the sea, we often picture sunny beaches, rolling waves, dolphins jumping through the surf. But beneath that sparkling surface lies an entirely different world. A world of stillness, of silence, of profound, ancient mystery. Tonight, we'll descend together into those depths. We'll discover places where no light has ever reached. We'll learn about creatures that seem almost alien. We'll explore landscapes more dramatic than anything on land. And through it all, I hope you'll find the same sense of calm that the ocean itself embodies, patient, timeless, and infinitely deep. So settle in, adjust your pillow, pull up your blanket, let your shoulders drop, unclench your jaw. There's nowhere you need to be, nothing you need to do. Just breathe, slowly and deeply, and let's begin our descent into the peaceful darkness of the deep ocean. Fact 1. The crushing weight. Our first stop takes us to the very bottom of the ocean, the deepest place on Earth. The Mariana Trench. It's located in the western Pacific Ocean, near Guam, and at its deepest point, a place called Challenger Deep. The ocean floor sits nearly 7 miles below the surface. 7 miles straight down into darkness. To put that in perspective, if you placed Mount Everest at the bottom of the Mariana Trench, its peak would still be more than a mile underwater. The entire mountain, the tallest on Earth, would be swallowed completely by the ocean, with room to spare. But the depth itself isn't what makes the Mariana Trench so extreme. It's the pressure. At the bottom of Challenger Deep, the pressure is over 8 tons per square inch. 8 tons. On every single square inch of surface area. Let's try to wrap our minds around that for a moment. Imagine an elephant, a full-grown African elephant, weighing around 8 tons. Now imagine that entire elephant balanced on your thumb. That's the pressure on every square inch at the bottom of the Mariana Trench. Or picture this, 50 jumbo jets, each weighing around 400 tons, stacked in a pile on top of you. That's the kind of force we're talking about. It's almost incomprehensible. Our brains aren't really designed to understand that level of pressure because we've never experienced anything remotely close to it. At sea level, where most of us spend our lives, we're under about 14.7 pounds per square inch of pressure from the Earth's atmosphere. We don't feel it because we're adapted to it. Our bodies are built for it. But that's nothing compared to the deep ocean. With every 33 feet you descend underwater, the pressure increases by another 14.7 pounds per square inch. So at 33 feet down, you're experiencing twice the pressure you feel at the surface. At 66 feet, it's 3 times. At 99 feet, 4 times. And it just keeps increasing, on and on, as you go deeper. By the time you reach the bottom of the Mariana Trench, at nearly 36,000 feet, you're experiencing over 16,000 pounds per square inch. 8 tons per square inch. The human body simply cannot survive that. A person exposed to that pressure would be killed instantly. Our lungs would collapse. Our bones would shatter. Any air spaces in our body would be compressed to nothing. And yet, remarkably, life exists down there. When scientists first began exploring the deep ocean, they assumed that nothing could live at such depths. The pressure was too great, the darkness too complete, the cold too intense. Surely, they thought, the deep ocean must be a lifeless void, a dead zone where nothing could survive. But they were wrong. When the first submersibles descended to the deepest parts of the ocean, they found life. Strange, wonderful, beautiful life. Fish swimming slowly through the darkness. Amphipods, shrimp-like creatures, scuttling across the seafloor. Sea cucumbers, jellyfish, even microbes, thriving in the sediment. How is this possible? How can anything survive under 8 tons per square inch? The answer lies in adaptation. These deep-sea creatures have evolved over millions upon millions of years to not just survive, but to thrive in this extreme environment. Their bodies are built differently than ours. Many of them have no air spaces at all, no lungs, no swim bladders, nothing that could be compressed. Their bodies are mostly water, and water is incompressible. So the pressure outside their bodies equals the pressure inside, and they feel nothing. Some deep-sea fish have bones that are more flexible, less dense than ours. Some have bodies that are almost gelatinous, able to flex and move with the pressure rather than resisting it. They've given up speed and strength in exchange for the ability to exist where almost nothing else can. There's something beautiful about that, isn't there? The way life adapts. The way it finds a path forward, even in the most impossible circumstances. These creatures don't fight against the pressure. They don't struggle or resist. They simply exist within it, perfectly adapted, perfectly at peace. The ocean itself embodies this same quality. It doesn't rush. It doesn't hurry. It moves according to its own rhythms, tides flowing in and out, currents circling the globe, water cycling from surface to depth and back again over centuries. The ocean is patient, steady, constant. Fact 2. Permanent midnight. Now let's talk about light. Or more precisely, let's talk about its absence. When you're standing on a beach on a sunny day, light is everywhere. It sparkles on the wave tops. It filters down through the water in dancing, shimmering beams. If you wade in and duck your head under, you can see light playing across the sandy bottom, creating rippling patterns that shift and sway with the movement of the water above. Light feels limitless on the surface. Even on cloudy days, there's still light, diffused and soft, but present. We're so accustomed to living in light that we rarely think about it. It's just there, always, a constant presence in our lives. But in the ocean, light is a limited resource. It's a precious commodity that grows scarcer with every foot you descend. Here's how it works. When sunlight hits the surface of the ocean, some of it bounces back, reflected into the sky. But most of it penetrates the water and begins traveling downward. As it does, the water itself absorbs the light, bit by bit, filtering out different colors as it goes. The first color to disappear is red. Red light has the longest wavelength, and it's absorbed quickly by water. By the time you're just 15 or 20 feet below the surface, red is already gone. That's why everything looks bluish-green when you're snorkeling or scuba diving. The reds and oranges have been filtered out. If you were to cut yourself underwater at that depth and look at the blood, it wouldn't look red. It would look dark green or even black, because there's no red light left to reflect off it. Blood is still red, of course, but without red light to illuminate it, your eyes can't perceive that color. As you go deeper, orange disappears next. Then yellow. By around 60 to 90 feet down, you're left with mostly blues and some greens. The water takes on that beautiful, ethereal quality that you see in underwater photography. Everything bathed in a dim, peaceful blue glow. Keep going deeper, though, and even the blue begins to fade. The light grows dimmer and dimmer. By around 600 feet, you're in what's called the twilight zone of the ocean. There's still light here, but it's faint. Ghostly. You can barely make out shapes. Everything is shadows and silhouettes. And then, at 3,280 feet, just a little more than half a mile down, you enter the midnight zone. Total darkness. Complete and absolute. This isn't like the darkness of your bedroom at night with the lights off. Your eyes adjust to that kind of darkness after a few minutes. You start to see shapes, shadows, maybe a faint glow from electronics or streetlights filtering through the curtains. Your pupils dilate, your rod cells activate, and you regain some ability to see. But in the midnight zone, there's nothing for your eyes to adjust to. No photons. No light particles at all. You could wait hours, days, years. Your eyes would never adjust because there's simply nothing there to see. It's not dim. It's not dark. It's the complete absence of light. This is a darkness that has existed for billions of years. Since the oceans first formed on Earth, sunlight has never penetrated to these depths. Not once. Not ever. The very water molecules down there have never known the touch of the sun. And this midnight zone, this realm of eternal darkness, makes up about 90% of the ocean's volume. Think about that for a moment. 90%. The vast majority of the ocean exists in complete darkness. When we picture the ocean, we tend to think of the surface, the sunlit shallows, the coral reefs bright with color. But those are just a thin skin on the surface. A sliver. The real ocean, the ocean that contains the most water, the most space, the most volume, is dark. Always has been. Always will be. It's almost eerie to contemplate, isn't it? All that space, all that water, all that life, existing in absolute blackness. Miles and miles of darkness stretching in every direction. But here's what's remarkable. The midnight zone is not lifeless. It's not empty. It's absolutely teeming with creatures. In fact, scientists believe the midnight zone may contain more biomass, more living tissue, than any other habitat on Earth. How is that possible? How can life flourish without light? Well, most life on land depends on photosynthesis. Plants capture sunlight and convert it into energy, and then animals eat the plants, and other animals eat those animals. It's a chain that begins with the sun. No sunlight, no photosynthesis, no food chain, no life. That's the basic formula. But in the midnight zone, life has found another way. The creatures here don't rely on photosynthesis. Instead, they rely on what falls from above. Dead fish, dead plankton, bits of waste and organic matter. Scientists call it marine snow, drifting down from the sunlit waters above. It falls slowly, like snowflakes, through the dark water, and the creatures of the deep feed on it. It's a different kind of existence. Slower, more patient. Food is scarce, so these animals have adapted to survive on very little. Many of them have slow metabolisms. They move slowly, conserving energy. Some can go months without eating. They've learned to wait. And then there's the bioluminescence, the light that life makes itself. In the midnight zone, where no sunlight reaches, many creatures have evolved the ability to create their own light through chemical reactions in their bodies. It's called bioluminescence, and it's absolutely stunning. There are jellyfish that pulse with blue light, their bells glowing like underwater moons. Fish with rows of light-producing organs along their sides, like little windows. Squid that flash patterns of light to communicate with each other, sending signals through the darkness. Some creatures use bioluminescence to lure prey, dangling a glowing lure in front of their mouths, waiting for curious fish to investigate. Others use it as camouflage, matching the faint light filtering from above to hide their silhouette from predators below. In the absence of sunlight, life created its own light. It found a way to glow from within. There's something almost magical about that. Something hopeful. These creatures have never known the sun, and yet they shine. They illuminate their own small corners of the darkness. They don't rage against the blackness, or wish for something different. They simply exist within it, adapted to it, at peace with it. And they glow. Fact 3. The Great Unknown. Here's something that might surprise you. It's a fact that sounds almost impossible when you first hear it, but it's absolutely true. We know more about the surface of Mars than we do about the bottom of our own ocean. Mars, a planet that's at its closest, around 34 million miles away from Earth. A world we've never set foot on, where no human has ever been. And yet, we have more detailed maps of its surface than we do of the seafloor beneath our feet. The same is true for the Moon. We've mapped the lunar surface in extraordinary detail. We can tell you about craters and mountains and valleys on the Moon with remarkable precision. But our own ocean floor? Much of it remains a mystery. Over 80% of the ocean remains unmapped, unobserved, and unexplored. 80%. Let that sink in for a moment. We live on a planet that is 70% water. Water covers most of our world. And yet we've only explored, truly explored, about 20% of what's down there. That means there's an area larger than all of the Earth's continents combined that we've simply never seen. Never studied. Never even mapped properly. Why is that? How is it possible that we can send rovers to Mars, land probes on asteroids, and photograph distant galaxies, but we can't map our own ocean floor. The answer comes down to the fundamental challenges of exploring underwater. Space exploration, as difficult as it is, has certain advantages. In space, there's no pressure. The vacuum of space isn't trying to crush your spacecraft. There's no water to corrode your equipment. Radio signals travel freely, so you can communicate easily with probes and satellites. But the ocean is different. The ocean is, in many ways, a much more hostile environment than space. First, there's the pressure we talked about earlier. Any vessel that descends to the deep ocean has to be built like a tank, with incredibly thick walls to withstand the crushing force of the water. That makes submersibles expensive, heavy, and difficult to build. A spacecraft can have relatively thin walls because it's only dealing with the pressure difference between the inside and the outside, about 14.7 pounds per square inch. But a deep-sea submersible at the bottom of the Mariana Trench has to withstand 16,000 pounds per square inch. The engineering challenges are immense. Then there's the issue of visibility. In space, you can see for enormous distances. You can use telescopes to observe galaxies billions of light years away. But in the ocean, visibility is measured in feet, maybe tens of feet if you're lucky. Water absorbs light, so even if you bring powerful lights with you, you can only see what's immediately around you. It's like trying to explore a pitch-black room with a flashlight that only illuminates a few feet in front of you. Communication is another problem. In space, we use radio waves to communicate with satellites and probes. Radio waves travel at the speed of light through the vacuum of space, so we can get signals from Mars in just a few minutes. But radio waves don't travel well through water. They're absorbed very quickly. That's why submarines have to surface or extend an antenna to communicate. They can't send radio signals while submerged. In the deep ocean, explorers often have to rely on acoustic signals, essentially sound waves. But sound travels much more slowly than light, and the messages are limited. You can't send high-resolution images or video through sound waves. So even when we do send submersibles to the deep ocean, the amount of data they can transmit back in real time is limited. And then there's the sheer size of the ocean. It's vast, incomprehensibly vast. The ocean covers about 139 million square miles. If you wanted to explore every square mile of the seafloor, sending a submersible down to look around, it would take thousands of years, maybe tens of thousands. We simply don't have the resources or the time to explore it all, piece by piece. So instead, we rely on sonar and other remote sensing techniques to map the ocean floor. Ships on the surface send sound waves down to the bottom, and by measuring how long it takes for the sound to bounce back, they can calculate the depth. Over time, by crisscrossing the ocean, ships can build up a map of the seafloor. But this process is slow and expensive. Even now, in the 21st century, much of our seafloor mapping is incomplete. We have general maps that show the major features: the mid-ocean ridges, the deep trenches, the continental shelves, but we're missing the details. It's like having a map of Earth that shows you where the continents are, but doesn't tell you where the mountains, rivers, or valleys are located. And because so much of the ocean remains unexplored, we keep discovering new things. Every time scientists send a submersible to a new location, they find something unexpected. New species, new geological features, new ecosystems. There are mountain ranges under the ocean that we've barely studied. The mid-ocean ridge system, for example, is the longest mountain range on Earth, over 40,000 miles long, wrapping around the globe like a seam on a baseball. It's bigger than the Himalayas, the Andes, and the Rockies combined. And yet, most people have never heard of it because it's underwater, hidden from view. There are underwater volcanoes, thousands of them, erupting in the darkness, creating new seafloor, releasing heat and chemicals that support entire ecosystems. There are deep-sea vents where superheated water, rich in minerals, pours out of cracks in the Earth's crust. Around these vents, life thrives, bizarre creatures that don't rely on sunlight at all, but instead get their energy from the chemicals in the vent water. There are canyons under the ocean deeper than the Grand Canyon. There are plains flatter and more featureless than any desert. There are places where the seafloor drops away suddenly, plunging thousands of feet in a matter of miles. And there are creatures down there that we're only just beginning to discover. Every deep-sea expedition brings back images and samples of animals that look like they're from another planet. Fish with transparent heads. Squid with eyes the size of dinner plates. Jellyfish that glow in colors we've never seen on land. Worms that grow to be several feet long, living in tubes near hydrothermal vents. Scientists estimate that we've identified maybe 10% of the species that live in the ocean. Maybe less. The other 90% are still out there, swimming, crawling, floating through the darkness, completely unknown to us. There's something humbling about that, isn't there? In an age where it feels like everything has been discovered, everything mapped, everything photographed and catalogued and posted online, it's remarkable to know that there are still vast areas of our own planet that remain mysterious. The ocean keeps its secrets. It's patient. It doesn't offer itself up easily. You have to work to understand it, to explore it. And even then, it only reveals a little bit at a time. There's a lesson in that, perhaps. In our modern lives, we're so used to having instant access to information. If we don't know something, we can look it up in seconds. We can see images of almost anywhere on Earth with a few clicks. We can read about any topic, any subject, any question we might have. But the ocean reminds us that some things can't be known instantly. Some things take time. Some things remain, for now, beyond our reach. And that's okay. That's more than okay. There's a beauty in mystery. A peace in accepting that we don't need to know everything, understand everything, map everything. Sometimes, the most profound wisdom lies in recognizing how much we don't know. How vast the unknown is. How small we are in comparison to the great mysteries of the world. The ocean has existed for billions of years, long before humans walked the earth, and it will continue to exist long after we're gone. It doesn't need us to understand it. It doesn't need us to explore it or map it or name every creature that lives within it. It simply exists, vast and deep and mysterious, holding its secrets close. Fact 4. Underwater waterfalls. When we think of waterfalls, we picture them on land. Niagara Falls, with its thundering cascade of water plunging over the edge. Victoria Falls in Africa, where the Zambezi River drops into a chasm with a roar that can be heard for miles. Angel Falls in Venezuela, the tallest waterfall on land, where water drops 3,212 feet from the top of a table mountain into the jungle below. These are magnificent, awe-inspiring natural wonders. They draw millions of visitors every year. People stand at viewing platforms, feeling the mist on their faces, hearing the constant roar of falling water. It's one of nature's most powerful displays. But here's something most people don't know. The largest waterfall on Earth isn't on land at all. It's underwater. Hidden beneath the surface of the ocean, completely invisible from above, is a waterfall that makes every terrestrial waterfall look small by comparison. It's called the Denmark Strait Cataract, and it's located between Greenland and Iceland, in the cold waters of the North Atlantic. This underwater waterfall drops 11,500 feet. That's more than 2 miles. To put that in perspective, it's nearly 3 times the height of Angel Falls, the tallest waterfall on land. If you stacked 3 Empire State Buildings on top of each other, the Denmark Strait Cataract would still be taller. Now, you might be wondering, how can there be a waterfall underwater? Isn't all the water already at the same level? How can water fall through more water? It's a fair question, and the answer lies in the fact that not all ocean water is the same. Water has different properties depending on its temperature and salinity, how salty it is. Cold water is denser than warm water. Salty water is denser than fresh water. And when waters with different densities meet, they don't always mix. Instead, the denser water sinks below the less dense water. In the Denmark Strait, cold water from the Arctic meets warmer water from the Atlantic. The Arctic water is incredibly cold, just a few degrees above freezing. This cold water is also quite salty. The combination of cold temperature and high salinity makes it very dense. Much denser than the warmer Atlantic water nearby. So what happens is this. The cold, dense Arctic water flows southward, and when it reaches the edge of the underwater ridge between Greenland and Iceland, it encounters the warmer Atlantic water. And instead of mixing, the cold water plunges down. It drops down the underwater slope, falling thousands of feet to the ocean floor below. It's a true waterfall, in every sense. Millions of cubic feet of water cascading downward every second. But it happens in slow motion, and it happens in darkness, far below the surface where no one can see it. The flow rate of the Denmark Strait Cataract is absolutely staggering. It carries about 175 million cubic feet of water per second. That's more than 2,000 times the flow rate of Niagara Falls. If you could somehow see this underwater waterfall, watch all that water plunging down into the depths, it would be one of the most spectacular sights on Earth. But of course, you can't see it. Not directly. It happens too deep, in water that's too dark and too cold for casual observation. Scientists have measured it using sophisticated instruments, sensors that can detect changes in water temperature, salinity, and flow. They've mapped it using sonar. But no human eye has ever witnessed it the way we can witness Niagara Falls or Victoria Falls. There's something almost poetic about that. The largest waterfall on Earth, and it's invisible. Hidden. A secret that the ocean keeps, flowing year after year, decade after decade, century after century, in the silent darkness of the deep. And the Denmark Strait Cataract isn't the only underwater waterfall. There are others scattered around the world's oceans, wherever cold, dense water meets warm, less dense water over an underwater ridge or slope. The Denmark Strait Cataract is just the largest and most dramatic. These underwater waterfalls play a crucial role in ocean circulation. They're part of what oceanographers call the thermohaline circulation, a global conveyor belt of ocean currents driven by differences in temperature and salinity. Cold water sinks at the poles, flows along the ocean floor toward the equator, gradually warms, rises, and then flows back toward the poles at the surface. This circulation helps distribute heat around the planet, moderating Earth's climate. So these hidden waterfalls, invisible though they are actually vital to life on Earth. They keep the ocean moving. They help maintain the balance of heat between the tropics and the polar regions. They're part of the great engine that drives our planet's weather and climate. It's remarkable when you think about it. Something so large, so powerful, so important, and yet completely hidden from view. Most people will live their entire lives without knowing these underwater waterfalls exist. And yet they're there, always, flowing in the darkness. There's a lesson in that, perhaps. Not everything important is visible. Not everything that matters is on display. Some of the most powerful forces in our lives, in our world, operate quietly out of sight. The way our heart beats without us thinking about it. The way our lungs draw breath while we sleep. The way the Earth spins and orbits the Sun, carrying us through space at thousands of miles per hour, and we don't feel a thing. So much happens beneath the surface. So much goes on in the hidden places, the deep places, where we can't see or measure or observe directly. And that's okay. That's how it should be. Not everything needs to be seen or understood. Some things can simply exist, doing their work quietly, in the dark. As you lie here tonight, your own body is performing countless tasks beneath the surface of your awareness. Your cells are dividing, repairing, renewing. Your digestive system is breaking down food, extracting nutrients. Your immune system is patrolling, protecting you from threats you'll never know existed. Your brain is processing, consolidating memories, working through problems even as you sleep. All of this happens without your conscious effort. You don't have to think about it, or manage it, or control it. Your body knows what to do. It has its own deep currents, its own circulation, its own hidden waterfalls of energy and chemical reactions flowing constantly beneath the surface. Fact 5. 750 degrees Fahrenheit water. Let's journey now to one of the strangest, most extreme environments anywhere on Earth. A place that seems to defy the very laws of nature as we understand them. A place where water, plain, ordinary H2O, reaches temperatures of 750 degrees Fahrenheit, and yet doesn't boil. Where life exists in conditions that would instantly kill almost anything we know. We're talking about hydrothermal vents. Specifically, a type called black smokers. These vents are found in the deepest parts of the ocean, usually along the mid-ocean ridges. Those underwater mountain ranges we mentioned earlier, where tectonic plates are spreading apart and new seafloor is being created. As the plates separate, cracks form in the Earth's crust. Seawater seeps down through these cracks, penetrating deep into the rock, sometimes traveling several miles below the seafloor. Down there, the water encounters magma, molten rock from the Earth's mantle, heated to over 2,000 degrees Fahrenheit. The seawater is superheated by this contact with magma, and it also picks up dissolved minerals from the surrounding rock: sulfur, iron, copper, zinc, and other elements. Then, because hot water is less dense than cold water, this superheated, mineral-rich water rises back up through the cracks. It shoots out of vents in the seafloor like underwater geysers, creating plumes of dark, particle-laden water that look like smoke. Hence the name, black smokers. The water emerging from these vents can reach temperatures of 750 degrees Fahrenheit. Some vents have been measured at even higher temperatures, up to 800 degrees Fahrenheit or more. Now, normally, water boils at 212 degrees Fahrenheit at sea level. That's when it transitions from liquid to gas, creating bubbles of water vapor. So how can water at the bottom of the ocean reach 750 degrees and not boil? The answer is pressure. The same crushing pressure we talked about earlier, the pressure that would flatten a human instantly. That pressure also changes the physical properties of water. Boiling isn't just about temperature. It's about the relationship between temperature and pressure. Water boils when the vapor pressure of the liquid equals the atmospheric pressure around it. At sea level, with atmospheric pressure at 14.7 pounds per square inch, water boils at 212 degrees. But increase the pressure, and you increase the boiling point. At the bottom of the ocean, where the pressure can be 16,000 pounds per square inch or more, the boiling point of water is much, much higher. Water can be heated to 750 degrees, even 800 degrees, and it remains liquid. No bubbles, no boiling, just incredibly hot water, superheated by the Earth's interior, blasting out of cracks in the seafloor. When this superheated water meets the near-freezing water of the deep ocean, usually around 35 to 39 degrees Fahrenheit, the minerals dissolved in the hot water precipitate out. They form solid particles that cloud the water, creating those dark plumes that give black smokers their name. Over time, these minerals build up around the vent, creating chimney-like structures that can grow to be several stories tall. Some of these chimneys are as tall as a 5- or 6-story building, all created by mineral deposits from the vent water. It's a harsh environment, to put it mildly. Imagine standing next to a vent. On one side, water hot enough to melt lead. On the other side, water just above freezing. Extreme temperature gradients, crushing pressure, total darkness. Water that's acidic and filled with toxic chemicals like hydrogen sulfide, which is poisonous to most forms of life. It sounds like the most inhospitable place imaginable. A literal hellscape at the bottom of the ocean. Surely, you'd think, nothing could live there. And yet, when scientists first discovered hydrothermal vents in 1977, they were shocked to find them teeming with life. Massive colonies of tube worms, some growing to be 6 feet long or more, clustered around the vents. Clams the size of dinner plates. Mussels, crabs, shrimp, fish, all thriving in an environment that should, by all rights, be completely sterile. How is this possible? The answer lies in a process called chemosynthesis. Most life on Earth relies on photosynthesis, the process by which plants and algae use sunlight to convert carbon dioxide and water into sugars, creating energy and releasing oxygen. It's the foundation of almost every ecosystem on the planet. Sunlight feeds plants, plants feed herbivores, herbivores feed carnivores. The sun is the ultimate source of energy for life as we know it. But at hydrothermal vents, there's no sunlight. It's too deep. Too dark. So life has found another way. Bacteria at the vents use chemicals from the vent water, particularly hydrogen sulfide, as an energy source. They combine the hydrogen sulfide with oxygen and carbon dioxide to produce organic compounds, essentially creating food from chemicals rather than sunlight. It's chemosynthesis instead of photosynthesis. These bacteria are the foundation of the vent ecosystem. They live on the surfaces of rocks, in the water around the vents, and even inside the bodies of larger animals. Those giant tube worms, for example, don't have mouths or digestive systems. Instead, they have specialized organs filled with chemosynthetic bacteria. The bacteria live inside the worms, producing food from the chemicals in the vent water, and the worms absorb the nutrients the bacteria produce. It's a symbiotic relationship. The worms provide a home for the bacteria, and the bacteria provide food for the worms. It's a completely separate tree of life, independent of the sun. An ecosystem that doesn't rely on photosynthesis at all. Some scientists believe that life on Earth might have actually originated at hydrothermal vents billions of years ago, before photosynthetic organisms evolved. The conditions at vents, hot water, dissolved minerals, chemical energy, could have provided the perfect environment for the first simple cells to form and thrive. And if life could originate at hydrothermal vents on Earth, could it also exist at similar vents on other worlds? Jupiter's moon Europa, for example, has a subsurface ocean beneath its icy crust. Saturn's moon Enceladus also has a subsurface ocean, and we know from spacecraft observations that it has hydrothermal activity. Could there be life at vents on Europa or Enceladus, living in the dark, relying on chemosynthesis rather than photosynthesis? It's one of the most exciting questions in astrobiology. But let's come back to Earth, to the black smokers at the bottom of our own ocean. There's something almost poetic about these places. They're harsh, yes, extreme, inhospitable by most standards, and yet they're also teeming with life, thriving, flourishing. It's a reminder that life is adaptable, resilient. Given time, given the right conditions, life finds a way. It doesn't need comfort. It doesn't need ease. It can thrive in the most unlikely places, in conditions that seem impossible. These creatures at the vents don't complain about the heat, or the pressure, or the darkness. They don't wish for sunlight or cooler water, or easier circumstances. They simply exist, adapted perfectly to their environment, making the most of what they have. They've turned a hellscape into a home. There's a lesson there, perhaps, for us. We all face difficult circumstances sometimes. Challenges, pressures, heat, darkness, times when everything feels harsh and hostile and overwhelming. It can be easy, in those moments, to feel like we can't survive, like the conditions are too extreme. But we're more resilient than we think, more adaptable. Like the creatures at the hydrothermal vents, we have the capacity to not just survive in difficult conditions, but to thrive, to find ways to extract energy and meaning even from the harshest circumstances, to build communities and connections even in the darkest places. You don't need perfect conditions to be okay. You don't need everything to be comfortable or easy. You have within you the same resilience that allows tube worms to flourish next to 750-degree water, that allows bacteria to create food from toxic chemicals, that allows entire ecosystems to exist in eternal darkness. Fact 6. The Jacuzzi of Despair. Deep in the Gulf of Mexico, at a depth of about 3,300 feet, there's something truly bizarre. Something that seems almost impossible. A lake. An actual lake, with shores and a surface, sitting at the bottom of the ocean. It's called a brine pool. And this particular one has earned a rather ominous nickname, the Jacuzzi of Despair. Now, you might be wondering, how can there be a lake at the bottom of the ocean? Isn't the whole ocean already a lake? Isn't it all just water? Well, yes and no. This is a special kind of lake. It's not freshwater. It's not even normal seawater. It's brine, water that's extremely salty, much saltier than the ocean around it. In fact, this particular brine pool is 5 times saltier than normal seawater. Here's how it forms. Deep beneath the seafloor in the Gulf of Mexico, there are ancient salt deposits. These deposits were left behind millions of years ago when the region was much shallower and seawater evaporated, leaving salt behind. Over time, these salt deposits were buried under layers of sediment. Seawater can seep down through cracks in the seafloor and dissolve some of this ancient salt, creating a super salty solution. This brine is denser than normal seawater, much denser. So dense that it doesn't mix with the regular ocean water. Instead, it pools in depressions on the seafloor, forming lakes and rivers of brine at the bottom of the ocean. From a distance, if you were in a submersible approaching one of these brine pools, it would look remarkably like a lake on land. You'd see a distinct surface, a clear boundary between the heavy brine below and the normal seawater above. You'd see shores where the brine meets the seafloor. If you were to maneuver your submersible right up to the surface of the brine, you could see waves on it, just like waves on a normal lake, created by ocean currents flowing over it. You could even see the refraction of light at the boundary, just like you see at the interface between air and water. If you dipped a mechanical arm into the brine, it would appear to bend at the surface, distorted by the difference in density between the brine and the seawater. It's surreal, otherworldly, a lake within an ocean. But this isn't a lake you'd want to swim in. Not if you were a fish, a crab, or anything else that lives in the ocean. Because this brine pool is deadly. First, there's the salinity. 5 times saltier than normal seawater means the salt concentration is so high that it's toxic. If a fish swims into the brine, the extreme salinity causes water to be drawn out of its cells through osmosis. The fish essentially becomes dehydrated and pickled, even though it's surrounded by water. But it gets worse. The Jacuzzi of Despair isn't just salty. It also contains extremely high levels of methane and hydrogen sulfide, both of which are toxic to most marine life. Methane is the same natural gas we use for heating and cooking. Hydrogen sulfide is the compound that gives rotten eggs their characteristic smell. In high concentrations, it's poisonous. So anything that swims into the Jacuzzi of Despair is hit with a triple threat: extreme salinity, toxic methane, and poisonous hydrogen sulfide. The result is almost immediate death. And here's the truly eerie part. The bodies don't decompose normally. The high salinity acts as a preservative. Dead fish, dead crabs, dead octopuses. They sink to the bottom of the brine pool and are essentially pickled, preserved. They can sit there for years, decades even, looking almost exactly as they did the moment they died. Scientists exploring these brine pools with submersibles have seen the seafloor around the edges littered with the preserved remains of creatures that made the fatal mistake of swimming into the brine. It's like an underwater graveyard, a monument to the dangerous curiosity of sea creatures that didn't realize the danger until it was too late. But here's where it gets interesting. Despite being deadly to most life, the brine pool isn't completely lifeless. At the edges, where the super salty brine meets the normal seawater, there's a narrow zone where specialized bacteria thrive. These bacteria can tolerate the high salinity and the toxic chemicals. In fact, they feed on the methane and hydrogen sulfide, using them as energy sources through chemosynthesis, the same process we talked about at the hydrothermal vents. And where there are bacteria, other life follows. Mussels cluster at the edges of the brine pool, hosting these bacteria in their gills and feeding on the nutrients the bacteria produce. There are also certain types of amphipods, small shrimp-like creatures, that can tolerate brief exposure to the brine. They dart in and out, feeding on the bacteria and the preserved remains of less fortunate creatures. So even in this deadly lake within an ocean, life finds a foothold. Not in the brine itself. That's too extreme. But at the edges, in the boundary zone where the deadly and the livable meet. Life is attracted to these edges, these margins, because that's where resources are concentrated. That's where the bacteria are, and where there are bacteria, there's food. It's a risky existence, though. One wrong move, one current that pushes you a little too far into the brine, and you're dead. Pickled. Preserved for decades on the floor of the Jacuzzi of Despair. There's something almost darkly poetic about that name, isn't it? The Jacuzzi of Despair. Jacuzzis are supposed to be relaxing, comforting. Warm water, bubbles, a place to unwind and let your troubles melt away. But this jacuzzi is the opposite. It's a trap, a deadly pool that looks inviting from a distance, but promises only death to those who enter. Scientists gave it that name partly as a joke, but also because there's some truth to it. The brine pool does bubble and ripple with the gases escaping from it, methane and hydrogen sulfide rising through the dense liquid. From a distance, it might look almost inviting, like a warm spring or a hot tub. But get close, and you realize it's anything but. It's a reminder that things aren't always what they seem. That danger can be hidden behind an attractive facade. That the ocean, for all its beauty, is also full of hazards and traps for the unwary. But it's also a reminder of something else. That even in the most toxic, most inhospitable environments, life persists. Maybe not in the center of the danger, but at the edges. In the margins, where the deadly meets the livable, life finds a way to exist, to adapt, to make use of even the harshest conditions. We all have our own jacuzzis of despair in life, don't we? Situations or relationships or habits that look inviting from a distance, that promise comfort or relief, but that are actually toxic. Things that seem like they'll help us relax or escape, but that actually pickle us, preserve us in a state we don't want to be in. Maybe it's a coping mechanism that's become harmful. Maybe it's a relationship that feels comfortable but is actually draining. Maybe it's a pattern of thinking that feels familiar but keeps us stuck. These things can be hard to recognize because they don't always look dangerous. Sometimes they look like comfort, like relief, like a warm pool to sink into. But just like the creatures that live at the edges of the Jacuzzi of Despair, we do best when we stay at the margins of these toxic things, when we recognize them for what they are and keep our distance, when we don't let ourselves be fully immersed in things that seem comforting but are actually harmful. Fact 7. The ghost ships of the Black Sea. Let's travel now to the Black Sea, that large body of water bordered by Ukraine, Russia, Georgia, Turkey, Bulgaria, and Romania. It's a sea with a long and rich history. Ancient Greeks established colonies on its shores. Roman ships sailed its waters. Byzantine traders crossed it carrying goods between Europe and Asia. And over the millennia, countless ships have sunk beneath its dark waves. But here's what makes the Black Sea unusual. Many of those shipwrecks are still there, sitting on the seafloor, in almost perfect condition. Ships that sank over 2,000 years ago look essentially as they did the day they went down. The wood is intact. The masts are still standing. Ropes are still coiled on the decks. Amphoras, ancient clay jars used to transport wine and olive oil, are still stacked in the holds. It's as if time has stopped for these ships, as if they've been frozen at the moment of their sinking, preserved in the darkness like artifacts in a museum. How is this possible? Why haven't these ships rotted away like shipwrecks in other oceans? The answer lies in a unique property of the Black Sea. It's anoxic. That means it has no oxygen. Well, more precisely, the upper layer of the Black Sea, about the top 10% or so, has oxygen, just like any normal body of water. Fish swim there. Plankton grow. It's a normal, living ocean environment. But below about 500 feet, something strange happens. The oxygen disappears. Completely. And it stays that way all the way down to the seafloor, which in some places is over 7,000 feet deep. About 90% of the Black Sea's volume is completely anoxic, zero oxygen. Why does this happen? It has to do with the Black Sea's unusual geography and the way water flows in and out of it. The Black Sea is connected to the Mediterranean Sea through a narrow strait, the Bosphorus, which runs through Istanbul. Water flows both ways through this strait. Salter, denser water from the Mediterranean, flows along the bottom of the strait into the Black Sea, while less salty water from the Black Sea flows out at the surface. The Black Sea also receives fresh water from several major rivers: the Danube, the Dnieper, the Don. All this fresh water sits on top of the salter water that came in from the Mediterranean, because fresh water is less dense than salt water. So you end up with two layers in the Black Sea that don't mix well: a fresher, less dense layer on top, and a salter, denser layer below. And when layers don't mix, oxygen can't circulate from the surface down to the depths. The deep water becomes isolated, stagnant. And when water sits stagnant for long enough, any oxygen that was in it gets used up by bacteria and other organisms. Eventually, all the oxygen is gone. And once it's gone, it can't be replenished because the layers don't mix. Now, here's why this matters for shipwrecks. Wood-eating organisms need oxygen. The most common culprits for destroying wooden shipwrecks are marine organisms called shipworms. They're not actually worms, but a type of mollusk, a clam that has evolved to bore through and eat wood. Shipworms have been the bane of wooden ships for as long as humans have been sailing. They burrow into the hull, eating the wood, weakening the structure, eventually reducing a ship to nothing but a few fragments. But shipworms, like all animals, need oxygen to survive. They can't live in anoxic water. Neither can most of the bacteria and fungi that would normally decompose wood. So when a ship sinks into the deep, anoxic layer of the Black Sea, it enters a realm where almost nothing can decay it. The wood-eating organisms can't survive there. The bacteria that would normally break down organic material can't function without oxygen. The ship just sits there, in the cold, dark, oxygen-free water preserved. It's like a natural time capsule. A graveyard of ships, frozen in time, waiting in the darkness. In recent years, underwater archaeologists have begun exploring these deep waters using remotely operated vehicles, robotic submersibles that can dive to depths too dangerous for human divers. And what they've found is extraordinary. There are Greek trading ships from 400 BCE, over 2,400 years old, with their masts still standing, their rudders still attached, their cargo still in the hold. The level of preservation is so good that you can still see the tool marks on the wood where ancient shipwrights shaped the planks. You can see the ropes, still coiled exactly where sailors left them. You can see pottery, intact and unbroken. One particularly famous shipwreck, discovered in 2017, is a Greek trading vessel that dates to around 400 BCE. It's believed to be the oldest intact shipwreck ever discovered. And intact is the key word here. This isn't just a few planks and some pottery. This is an entire ship, complete and whole, looking much as it did over 2 millennia ago. Archaeologists can study these ships and learn things about ancient shipbuilding techniques that would be impossible to learn any other way. They can see exactly how the planks were fitted together, how the masts were stepped, how the rigging was arranged. It's like having a window into the past, a direct view of ancient maritime technology. But it's not just ancient ships down there. There are medieval vessels, Ottoman warships, ships from the Age of Sail, even ships from World War II. The Black Sea has been a crossroads of history for thousands of years, and all of that history is preserved in its depths. It's eerie when you think about it. All those ships, all those crews, all those stories, still down there. The ships that carried Greek colonists to new lands. The merchant vessels loaded with amphoras of wine. The warships that fought in long-forgotten battles. The fishing boats that simply got caught in a storm and never made it home. And they're all waiting in the darkness, perfectly preserved, exactly as they were the moment they sank. The crews are long gone, of course. Human remains don't preserve the same way wood does. But the ships themselves remain, ghost ships in the truest sense. Remnants of the past, haunting the present. There's something beautiful about it, though. These ships, which once sailed the surface, which once felt the sun and the wind and the spray of waves, they've found a kind of peace in the depths. They're no longer battered by storms, no longer at risk of running aground or being attacked. They're simply resting, quietly, in the still, dark water. Time moves differently down there. On the surface, things change constantly. Ships are built, they sail, they age, they rot, they're replaced. Empires rise and fall. Cities are built and abandoned. The world churns and changes and never stops moving. But in the anoxic depths of the Black Sea, time slows almost to a stop. The ships that sank there 1,000 years ago look much the same today as they did then. Change happens so slowly that it's almost imperceptible. There's a kind of immortality in that preservation, a kind of peace in that stillness. We live our lives on the surface, in the oxygenated layer, where everything is in motion, where decay and change are constant. We age. We wear down. We feel the passage of time in our bodies, in our faces, in our memories. But maybe deep down, there's a part of us that remains unchanged. A core that sits in the anoxic depths of our being, preserved and whole, untouched by the surface storms. The person we were when we were young, they're still in there somewhere, aren't they? Preserved. Waiting. Like a ship in the darkness. Maybe who we really are, our essential self, doesn't change as much as we think. Maybe we're like those Greek trading ships, fundamentally the same vessel, even if we've been sailing for years, even if we've weathered storms and calm seas, and everything in between. There's a comfort in that thought, that beneath all the surface change, beneath all the ways we adapt and grow and respond to life's challenges, there's something constant, something preserved, something that remains quietly in the depths. Fact 8. The ice finger of death. Let's travel now to the coldest oceans on Earth, the waters around Antarctica. These are some of the most extreme marine environments on the planet. The water temperature hovers just above freezing, typically around 28 to 29 degrees Fahrenheit. That's below the freezing point of freshwater, but seawater can stay liquid at these temperatures because the salt lowers its freezing point. Life in these frigid waters has adapted remarkably. Fish have antifreeze proteins in their blood that prevent ice crystals from forming. Seals and penguins have thick layers of blubber for insulation. Everything moves a little slower in the cold, metabolism slowed to conserve energy. But there's a phenomenon in these Antarctic waters that seems to come from another world entirely. Something so strange, so otherworldly, that when it was first filmed by the BBC for the series Frozen Planet in 2011, many people couldn't believe it was real. It's called a brinacle, and it's been given another, more evocative name, the ice finger of death. Here's how it forms. During the Antarctic winter, sea ice forms on the ocean surface. But when seawater freezes, the ice crystals that form are actually pure water. They exclude the salt. So all that salt has to go somewhere. It gets concentrated into pockets of super salty brine within the ice. This brine is incredibly dense, much denser than normal seawater, because of its extreme salinity. And it's also very, very cold. Colder than the seawater below. Sometimes, this brine finds a crack or channel in the sea ice, and gravity does its work. The dense, super cold brine begins to sink, dripping down through the seawater like an underwater waterfall. But here's where it gets strange. Because this brine is so cold, colder than the freezing point of the seawater it's sinking through, it actually freezes the seawater around it as it descends. Ice forms around the stream of descending brine, creating a hollow tube of ice. An icicle growing downward through the water. A brinacle. From a distance, it looks almost delicate, almost beautiful. A slender finger of ice reaching down from the underside of the sea ice toward the seafloor below. It grows slowly, steadily, driven by the constant drip of super cold brine from above. The brinacle extends downward, growing longer and longer, until finally it reaches the seafloor. And when it does, something remarkable and terrible happens. The super cold brine spreads out across the seafloor like a liquid, a river of freezing death flowing along the bottom. And everything it touches freezes. Instantly. Starfish, moving slowly across the seafloor, are overtaken by the spreading brine. Ice forms around them, encasing them. They stop moving, frozen solid in a matter of seconds. Sea urchins, anemones, anything that can't move fast enough to escape. They're all caught, trapped in ice, killed by the sudden extreme cold. It's like something out of a horror movie. A finger of ice reaching down from above, touching the seafloor, and spreading death in all directions. Everything in its path is frozen, entombed in ice, killed without warning. The footage from Frozen Planet shows this happening in time-lapse. You can see the brinacle growing downward, reaching, until it finally touches bottom. And then you see the brine spreading out, and the starfish in its path slowing, stopping, freezing. It's mesmerizing and horrifying at the same time. The starfish don't even seem to know what's happening. They're cold water animals. They're used to frigid temperatures. But this is beyond cold. This is a cold that even they can't survive. A cold so extreme that it freezes seawater solid in seconds. And once they're frozen, they're dead. The ice crystals that form in their tissues rupture their cells. Even if the ice were to melt, they wouldn't recover. They're gone, entombed in ice on the seafloor, victims of the ice finger of death. It sounds almost mythological, doesn't it? Like something from an ancient legend. The finger of death reaching down from the heavens to strike down the unwary. But it's real. It's a natural phenomenon, driven by simple physics, density, temperature, salinity. Nothing supernatural about it. And yet it seems supernatural. It seems impossible. Scientists had theorized about brinicles for decades before they were actually filmed. Divers had occasionally seen strange ice formations under Antarctic sea ice, hollow tubes of ice that didn't quite make sense. But no one had actually witnessed one forming and reaching the seafloor until those BBC cameras captured it in 2011. It took patience to film. Brinicles are unpredictable. You can't know where or when one will form. The camera crew had to set up time-lapse cameras under the ice and wait, checking them periodically, hoping they'd get lucky. And eventually they did. They captured the entire process, from the first drip of brine to the moment it touched the seafloor and spread out, freezing everything in its path. It's a reminder that even now, in the 21st century, there are still natural phenomena we're only beginning to document and understand. Still things happening in the ocean that we've barely witnessed. Still mysteries lurking in the cold, dark waters of the world. But there's also something almost beautiful about the brinicle, in a dark sort of way. The ice formations themselves are elegant. Delicate tubes and crystals, intricate structures created by the interplay of temperature and salinity. Nature creates beauty even in the act of destruction. And for the starfish and urchins, death comes quickly. They don't suffer for long. One moment they're moving slowly across the seafloor, living their slow, cold lives. The next moment, they're frozen, locked in place, their last moment preserved forever in ice. It's a clean death, in a way. Instant. Absolute. No decay, no slow fading. Just a sudden transition from life to ice. From movement to stillness. From being to not being, in the span of seconds. We all fear death, of course. It's natural. It's human. We want to keep living, keep experiencing, keep being. The thought of ending, of stopping, of that final moment, it frightens us. But maybe there's some comfort in knowing that when death comes, whenever it comes, however it comes, it's just a transition. Just a moment. A line we cross from one state to another. The starfish doesn't know it's dying. One moment it's there, and the next it's not. No fear. No suffering. Just a quiet transition. Fact 9. The blue hole bodies. Off the coast of Belize, about 43 miles from the mainland, there's a geological formation that's become famous around the world. It's called the Great Blue Hole, and from the air, it's absolutely stunning. It's a nearly perfect circle in the shallow, turquoise waters of the Caribbean. A circle of deep, dark blue, about 1,000 feet across. The contrast is striking. All around it, the water is shallow and bright, the typical beautiful blue-green of the Caribbean. But the blue hole itself is dark, almost navy blue, because it's deep. Very deep. The Great Blue Hole is actually an underwater sinkhole, a vertical cave that was formed thousands of years ago during the last ice age, when sea levels were much lower. Back then, this area was above water, and rainwater carved out a limestone cave system. The cave had a large chamber with stalactites hanging from the ceiling, stalagmites rising from the floor, all the typical features of a limestone cave. But then the ice age ended. The glaciers melted, sea levels rose, the land sank, and the cave was flooded. The roof eventually collapsed, creating this circular opening, a hole leading down into the flooded cave below. Today, the blue hole drops down about 400 feet from the surface to the floor of the ancient cave. It's become a bucket list destination for scuba divers from around the world. The chance to dive into this stunning geological formation, to see the ancient stalactites hanging in the water, to explore the rim of the hole. It's an experience unlike any other. But the blue hole holds secrets. Dark secrets. and dangers that not every diver is prepared for. At around 300 feet deep, there's what divers call a dead layer. It's a layer of water that contains no oxygen, anoxic, just like the depths of the Black Sea we talked about earlier. But in the blue hole, this anoxic layer also contains high concentrations of hydrogen sulfide, that same toxic gas we discussed at the hydrothermal vents. This hydrogen sulfide comes from the decomposition of organic matter, algae, bacteria, anything that dies and sinks down into the hole. In the absence of oxygen, certain bacteria break down this organic matter and produce hydrogen sulfide as a waste product. Over time, it accumulates in a layer, creating a toxic zone. When divers descend through this layer, they can actually see it. The water changes color. It becomes darker, murkier. There's a visible boundary, almost like a cloud layer. And below that boundary, visibility drops to almost zero. The hydrogen sulfide makes the water milky, opaque. You can barely see your hand in front of your face. Most recreational divers don't go anywhere near this deep. Recreational scuba diving is typically limited to about 130 feet, sometimes 160 feet for advanced divers with special training. At those depths, you're still in the clear, oxygenated water above the blue hole's dead layer. You can see the stalactites, explore the rim, enjoy the dive, and surface safely. But some divers push further. Technical divers, using special equipment, special gas mixtures, special training, they go deeper. And some of them have gone past the dead layer, down into the depths of the blue hole. And there, in the toxic, oxygen-free water below 300 feet, they've found something chilling: human remains. Bodies of divers who went too deep and never came back. Divers who pushed past their limits, past their training, past the point of safe return. Maybe they experienced nitrogen narcosis, a condition caused by breathing compressed nitrogen at depth, which can cause confusion, poor judgment, euphoria. Divers sometimes describe it as feeling drunk. At extreme depths, it can be severe enough to cause fatal mistakes. Or maybe they simply ran out of air, or experienced equipment failure, or got disoriented in the darkness and couldn't find their way back up. There are many ways for a deep dive to go wrong, and in a place as remote and deep as the blue hole, rescue is often impossible. When a diver dies in the blue hole and sinks below the dead layer, something unusual happens. The body is preserved. The lack of oxygen means there are no organisms that can decompose it. The hydrogen sulfide acts as a preservative. The cold water at that depth, significantly colder than the surface, also slows decomposition. So the bodies remain, sitting on the floor of the ancient cave, in the darkness, in the toxic water, essentially mummified. Preserved. Waiting. Recovery is nearly impossible. The depth alone makes it extremely dangerous. At 300 feet or more, you're at the very edge of what's survivable for human divers, even with technical training and equipment. The toxic hydrogen sulfide is another hazard. And the bodies are often covered in silt, part of the seafloor now, difficult to reach and even more difficult to bring to the surface. So in most cases, they stay there. The families of lost divers are told that their loved ones are in the blue hole, but they can't be recovered. They remain there, in the darkness, in the dead layer, entombed in the underwater cave. It's haunting to think about. These divers came seeking adventure, seeking the thrill of exploring one of the world's most beautiful dive sites. They descended into the blue, into the spectacular circle of deep water surrounded by shallow reef. Maybe they were experienced. Maybe they were overconfident. Maybe they just made one mistake, one bad decision, and it cost them everything. And now they're part of the blue hole itself, part of its mystery, part of its danger, a warning to others who might be tempted to push too deep, to go beyond the limits of safe diving. The diving community knows about these bodies. It's not something that's widely advertised to tourists. Belize doesn't want to scare away the divers who bring tourism dollars to the region. But among technical divers, among those who dive deep and explore extreme sites, it's known. The Great Blue Hole is beautiful, but it's also deadly. And it keeps its dead. There's something primally unsettling about this, isn't there? The thought of bodies in the deep, preserved in darkness, unreachable. It touches on ancient fears. The fear of drowning, the fear of being trapped, the fear of being lost and never found. We want to believe that when someone dies, their body will be recovered, that they'll be brought home, that they'll be buried properly, with rituals and mourning and closure. But sometimes that doesn't happen. Sometimes the ocean keeps its dead. Sometimes the depths refuse to give up what they've taken. The blue hole is a reminder of the ocean's power, of its indifference to human life, human desires, human grief. The ocean doesn't care if you're an experienced diver or a novice. It doesn't care if you have a family waiting for you on the surface. It doesn't care about your dreams or your plans or your reasons for being there. The ocean simply exists, following its own rules. Rules of pressure and salinity and oxygen and depth. And if you violate those rules, if you push too far into its realm without the proper respect and preparation, it will claim you. Not out of malice, not out of cruelty, simply because that's what happens when human bodies encounter conditions they weren't built to survive. But here's something important to remember. Most divers who visit the blue hole come back safely. Thousands of people have dived there over the years, and the vast majority have beautiful, safe experiences. They stay at recreational depths, they follow their training, they respect the limits, and they surface with incredible memories and stunning photographs. It's only those who push beyond the limits, who ignore the warnings, who go too deep. It's only they who don't return. The blue hole isn't inherently deadly. It's deadly only if you don't respect it. Only if you treat it as a challenge to conquer, rather than a place to visit with humility and care. There's a lesson there for life in general, perhaps. We all have limits. Depths we shouldn't push past. Places we shouldn't go, at least not without proper preparation and support. And it's okay to acknowledge those limits. It's okay to stay in the safe zone, the clear water, the place where you can see and breathe and function. You don't have to push into the dead layer to prove something. You don't have to go deeper than you're ready for. You don't have to test your limits to the breaking point. Sometimes the wisest thing you can do is recognize where the boundary is, where the clear water meets the toxic layer, and stay on the safe side of it. There's no shame in that, only wisdom. Fact 10. The Milky Seas. For centuries, sailors have told stories about strange stretches of ocean that glow at night. Not just the sparkles of bioluminescence that you sometimes see when you disturb the water, waves breaking on a beach and leaving trails of blue-green light, or a boat's wake glowing in the darkness. Those are common enough, caused by tiny organisms called dinoflagellates that emit light when disturbed. No, these stories were about something much larger, much stranger. Entire sections of ocean, stretching for miles in every direction, glowing with a steady, milky white light. The sailors called them Milky Seas, and their descriptions were almost otherworldly. They described sailing into water that glowed with an eerie, uniform luminescence. Looking down from the deck of the ship, they couldn't see the water itself, just a field of soft, milky light, as if the ocean had been replaced with glowing fog. Looking out to the horizon, they could see this glow stretching away in all directions, sometimes as far as the eye could see. And looking up at the sky, they reported that the glow was bright enough to illuminate the sails and cast faint shadows on the deck. Some accounts described sailing through these milky seas for hours, even days. The ship would enter the glowing water at dusk, and still be surrounded by it at dawn. Miles and miles of ocean, all glowing with that strange, steady, milky light. For a long time, these stories were dismissed as sailors' tales. Exaggerations. Myths. Maybe something that happened once in a while on a small scale, but certainly not the enormous, persistent phenomena the sailors described. But the accounts kept coming. Logbooks from the 19th century, reports from the early 20th century, even modern accounts from cargo ships and fishing vessels. Sailors from different eras, different cultures, different parts of the world, all describing the same phenomenon. Vast stretches of ocean that glowed at night with a uniform, milky light. Scientists started to take the reports seriously. If so many independent observers were describing the same thing, maybe there was something to it. But how could you study a phenomenon that appeared unpredictably, in the middle of the ocean, often in remote areas far from research vessels. The breakthrough came with satellites. In the 1990s and 2000s, scientists realized that some satellites designed to detect city lights and other nighttime illumination might also be able to detect Milky Seas if they were bright enough. And in 2005, they found one. A satellite captured images of a Milky Sea in the Indian Ocean, northwest of Australia. It was enormous. The glowing area covered approximately 6,000 square miles, roughly the size of Connecticut, and it persisted for 3 consecutive nights before dissipating. Finally, there was proof. Milky Seas weren't just sailors' tales. They were real, and they were even larger than many of the historical accounts had suggested. But what causes them? What could possibly make thousands of square miles of ocean glow with a steady, uniform light? The answer, scientists discovered, is bacteria. Specifically, a type of bioluminescent bacteria called Vibrio havii. These bacteria live in the ocean, and under the right conditions, they can bloom. Their population explodes, multiplying rapidly until there are astronomical numbers of them in the water. We're talking about trillions upon trillions of bacteria concentrated in a particular area. And these bacteria glow. They produce light through a chemical reaction, the same basic process we see in fireflies and many other bioluminescent organisms. But unlike dinoflagellates, which only glow when disturbed, these bacteria glow constantly. They produce a steady, continuous light. When you have trillions of glowing bacteria concentrated in one area, all glowing at once, the cumulative effect is that eerie, milky luminescence that sailors have been describing for centuries. Each individual bacterium produces just a tiny amount of light, but multiply that by trillions, and you get enough light to be seen from space. Enough light to illuminate ships' sails. Enough light to create that strange, otherworldly glow. But here's where it gets really interesting. Scientists have discovered why these bacteria glow. It's not random. It's not just a quirk of their biology. The bacteria are glowing for a very specific reason: to get eaten. It sounds counterintuitive, doesn't it? Why would an organism want to get eaten? But for these bacteria, being eaten is actually part of their survival strategy. The bacteria live most of their lives floating freely in the ocean. But their ideal habitat, the place where they really thrive, is inside the gut of a fish. Inside a fish's digestive system, they have access to nutrients, protection from predators, and a stable environment. It's like a perfect home for them. But how do they get there? They need to be eaten by a fish. And that's where the glowing comes in. When the bacteria reach a high enough density, when there are enough of them concentrated in one area, they start to glow. This is controlled by a process called quorum sensing. Basically, the bacteria can detect when there are a lot of other bacteria nearby, and when the population reaches a threshold, they all start glowing at once. The light attracts fish. Fish are drawn to the glow, curious or perhaps mistaking it for food or other fish. They swim into the glowing water and gulp it down, taking in mouthfuls of bacteria with each swallow. And that's exactly what the bacteria want. They get swallowed, they pass into the fish's gut, and suddenly they're in their ideal habitat. Mission accomplished. It's a remarkable strategy. A form of hitchhiking, really. The bacteria create a light show to attract their own transportation to a better home. It's manipulation on a bacterial level, but it works. The fish well, they probably don't get much out of the deal, but they don't seem to be harmed either. And the bacteria get exactly what they want. So when sailors encounter a Milky Sea, what they're really witnessing is trillions upon trillions of bacteria, all glowing in unison, all trying to attract fish, all hoping to be eaten and transported to their ideal habitat. It's a massive coordinated effort by one of the simplest forms of life on Earth, creating one of the most spectacular natural light displays in the world. There's something beautiful about that, isn't there? These tiny single-celled organisms, invisible to the naked eye, working together, if you can call it that, to create something visible from space. Something that has awed and mystified sailors for centuries. Something that turns the ocean into a field of light. It's a reminder that even the smallest things, when they come together in sufficient numbers, can create something magnificent. One bacterium glowing alone, you'd never notice it. You couldn't see it even if you tried. But trillions of them glowing together? That creates a phenomenon that can be seen from orbit. That can light up thousands of square miles of ocean. That can illuminate a ship's sails in the middle of the night. Sometimes we feel small, don't we? Insignificant. Like our individual contributions don't matter. Like we're just one tiny organism in a vast ocean. And what difference could we possibly make? But maybe the Milky Seas offer a different perspective. Maybe they show us that small things, when they work together, when they coordinate, when they all light up at the same time, maybe that can create something extraordinary, something visible, something that changes the darkness into light. You don't have to be big to matter. You don't have to be powerful or important or special. You just have to be willing to add your light to the collective glow, to shine in your own small way, trusting that when you combine your light with others, something beautiful emerges. Fact 11. Deep sea gigantism. Let's talk about size, about proportion, about the strange ways that life adapts to extreme environments. On land, there are general rules about how big animals can grow. Insects, for example, are limited in size by the way they breathe. They don't have lungs like we do. Instead, they have a system of tubes called tracheae that deliver oxygen directly to their tissues. This system works fine for small creatures, but it doesn't scale up well. The larger an insect gets, the harder it is for oxygen to diffuse through those tubes to reach all the tissues. That's part of why you don't see insects the size of dogs or cats. Physics and biology conspire to keep them small. But in the deep ocean, some of these rules seem to break down. Or rather, they shift. Different pressures, literally and figuratively, create different outcomes. And one of the most striking outcomes is something scientists call deep sea gigantism. Creatures that would be small in shallow water grow to enormous sizes in the deep. We're talking about animals that have close relatives in shallow water or on land, relatives that are measured in inches or centimeters. But in the deep ocean, these same types of creatures grow to startling, almost monstrous proportions. Take the giant isopod, for example. If you've ever seen a pillbug or a roly-poly, those little armored creatures that curl up into a ball when you touch them, then you've seen an isopod. On land, they're typically about half an inch long. Cute, really. Harmless. The kind of thing kids play with in gardens. But the giant isopod, which lives in the deep ocean, grows to be up to 2.5 feet long. 2.5 feet. That's the length of a small dog. These things can weigh up to 3.5 pounds. And they look exactly like what they are, enormous underwater pillbugs. Enormous underwater cockroaches, if you want to be less charitable about it. They have fact armored bodies, multiple legs, long antennae, compound eyes, all the features of their tiny terrestrial cousins, just scaled up to nightmare proportions. If you saw one crawling across your floor, you'd probably run screaming from the room. But in the deep ocean, this is normal. This is just how isopods grow when they're not constrained by the limitations of terrestrial life. Or consider sea spiders. On the surface, in shallow water, sea spiders are delicate little creatures with leg spans measured in millimeters or centimeters. They're barely noticeable, creeping slowly across rocks and coral, feeding on soft-bodied animals like hydroids and anemones. But in the deep ocean, sea spiders can have leg spans of over 20 inches. Some species can reach up to 2 feet across. They look like something out of a science fiction movie. All legs, with a tiny body in the center, impossibly long limbs reaching out in all directions. They move in slow motion across the seafloor, those long legs carrying their tiny bodies with an eerie, deliberate grace. Why does this happen? Why do creatures grow so much larger in the deep ocean? Scientists have several theories, and the truth is probably a combination of factors. First, there's the cold. The deep ocean is frigid. Temperatures hover just a few degrees above freezing in most deep-sea environments. Cold water holds more dissolved oxygen than warm water. So even though the deep ocean is dark and distant from the surface, where oxygen is produced by photosynthesis, there's still plenty of oxygen available. And with more oxygen available, larger body sizes become possible. Second, there's the pressure. While crushing pressure is a challenge in many ways, it also creates certain advantages. In high-pressure environments, cells can be larger and metabolic processes can work differently. The constraints that limit size in low-pressure environments don't apply in the same way. Third, and perhaps most importantly, there's the scarcity of food. In the deep ocean, food is rare. We talked earlier about marine snow, the constant drift of dead material from the surface down to the depths. But it's not much. It's a sparse, unpredictable food supply. In environments where food is scarce, there's an evolutionary advantage to growing large. Larger bodies have lower metabolic rates relative to their size. A giant isopod, with its 2.5-foot body, doesn't need to eat proportionally more than a small isopod. In fact, it can survive much longer without food. Giant isopods in aquariums have been known to go 5 years or more without eating. 5 years. They can essentially shut down their metabolism and wait, patient as stones, for food to arrive. Smaller creatures can't do that. They have higher metabolic rates relative to their body size, which means they need to eat more often. In a food-scarce environment like the deep ocean, that's a disadvantage. So over evolutionary time, creatures in the deep tend to get larger. Size becomes a survival strategy. There's also less predation pressure in the deep. In shallow water, being large can make you a target. Predators are everywhere, and a big, slow-moving creature is an easy meal. But in the deep ocean, predators are fewer and farther between. There's less danger in being large and slow. You can afford to lumber across the seafloor taking your time, because there's simply less around that might eat you. So you end up with these giants. Creatures that look like they've stepped out of a prehistoric era or an alien world. Isopods the size of small dogs. Sea spiders with leg spans measured in feet. Amphipods, those shrimp-like creatures we mentioned before, that grow to 6 inches or more in the deep, when their shallow water cousins are barely an inch long. There are giant squid, of course, possibly reaching 40 feet or more in length. Giant tube worms at hydrothermal vents that grow to 6 or 8 feet long. Japanese spider crabs with leg spans that can reach 12 feet from claw to claw. It's a world of giants. Slow-moving, patient, energy-conserving giants, adapted to life in a cold, dark, food-scarce environment. They live their lives in slow motion, growing slowly, moving slowly, metabolizing slowly, reproducing slowly. Everything is slowed down, stretched out, enlarged. There's something almost dreamlike about it, isn't there? This world where the normal rules don't apply. Where small creatures become giants. Where time moves differently. Where a 2-foot pillbug is just another resident of the neighborhood. Nothing remarkable, just going about its business in the eternal darkness. It challenges our sense of what's normal. What's possible? We think we know how big a pillbug should be, how big a sea spider should be. We have these categories in our minds, these expectations based on what we see in our everyday lives. But the deep ocean doesn't care about our expectations. It operates according to its own rules, its own pressures, its own logic. And in that environment, giants are born. Maybe there's a lesson there about perspective, about how the rules that govern one environment don't necessarily apply to another, about how creatures, including us, adapt to the circumstances we find ourselves in. In one environment, staying small might be the key to survival. In another environment, growing large might be the answer. There's no universal rule, no one right way to be. It all depends on context, on circumstances, on the specific challenges you're facing. You might feel sometimes like you're not the right size for your life. Too big, too visible, too much. Or too small, too invisible, not enough. But maybe you're exactly the right size for your environment. Maybe you've adapted, consciously or unconsciously, to the pressures and circumstances you face. Maybe you're a giant in a deep-sea environment, or a small, quick creature in a shallow water environment, and both are exactly right for where you are. Fact 12. The parasitic husband. Now we come to one of the strangest, most unsettling reproductive strategies in all of nature. It's something that sounds like it came from a horror movie, Something so bizarre that when scientists first discovered it, they could hardly believe it was real. We're talking about the anglerfish. Specifically, the deep-sea anglerfish. You've probably seen pictures of anglerfish before. They're one of the most recognizable deep-sea creatures, often used in documentaries and books to represent the strangeness of the deep ocean. They have enormous mouths filled with long, needle-like teeth. They have that distinctive bioluminescent lure, a modified dorsal fin spine that extends in front of their face, tipped with a glowing bulb of light. They use this lure to attract prey in the darkness, dangling it like a fishing rod, waiting for curious fish to investigate. When something gets close enough, the anglerfish strikes with shocking speed, its enormous jaws engulfing the prey whole. They're frightening to look at. Monstrous, really. All mouth and teeth, and that eerie glowing lure. They look like something from a nightmare. But here's what most people don't know. The anglerfish we see in pictures, the monster with the huge mouth and the glowing lure, that's the female. And she's impressive. Some species of female anglerfish can grow to be 3 feet long. They're apex predators in their environment, formidable hunters despite their relatively small size compared to other ocean predators. The male anglerfish, on the other hand, well, he's not impressive at all. He's tiny. Absolutely tiny. Some male anglerfish are less than an inch long. They're dwarfed by the females of their species, sometimes 100 times smaller. A male anglerfish next to a female is like a mouse standing next to a large dog. And his life is very different from hers. He doesn't have the enormous mouth. He doesn't have the fearsome teeth. He doesn't have the glowing lure. In fact, he barely has anything. He's essentially a swimming reproductive organ, and his entire existence revolves around one goal: finding a female. This is where it gets really strange, and really disturbing. When a male anglerfish hatches, he has a very short window of time to find a female. He doesn't eat. He can't eat, really. His digestive system is minimal. He lives off stored energy from his larval stage, and that energy won't last long. Days maybe. A week or 2 at most. So he swims through the darkness, guided by pheromones released by females, desperately searching for a mate before his energy runs out. The deep ocean is vast and empty, and the chances of finding a female by random chance are infinitesimally small. It's like trying to find one specific person somewhere on the entire planet, while blindfolded, while that person is also moving. Most males probably never find a female. They simply run out of energy and die, their brief lives ending without ever fulfilling their biological purpose. But if a male gets lucky, if he happens to encounter a female, something remarkable and horrifying happens. He bites into her, usually on her belly, though sometimes on her side or back. And then, he doesn't let go. He never lets go. He bites down and holds on, and his mouth begins to fuse with her skin. Over the course of days and weeks, something even stranger happens. His body begins to fuse with hers. Not just his mouth, his entire body. The tissues merge. His circulatory system connects to hers. His blood vessels grow into her blood vessels. He essentially becomes part of her body, a parasitic appendage. And as this fusion progresses, he begins to lose things. His eyes degenerate. He doesn't need them anymore. He's not going anywhere. His fins wither away. Why would he need fins? He's not swimming. His internal organs, most of them, anyway, atrophy and disappear. His digestive system? Gone. His heart? Reduced to almost nothing, or gone entirely in some species. What's left is barely recognizable as a fish. Barely recognizable as a separate organism. He's just a small bump on the female's body, a vestigial attachment. And inside that bump, the only organs that remain functional are his testes. He's become nothing but a permanent, living sperm-producing appendage attached to the female. When she's ready to release her eggs, his sperm is right there, always available. She doesn't need to search for a mate. She doesn't need to worry about finding a male when the time is right. She's carrying him with her, literally part of her body, ready to fertilize her eggs whenever she chooses. And here's the really wild part. Some female anglerfish have multiple males attached to them. Scientists have found females with 2, 3, Even 8 males fused to their bodies. Imagine that. 8 former fish, now just bumps on her skin, all producing sperm, all completely dependent on her for survival. Because that's the thing. Once the male fuses with the female, he's completely dependent on her. He gets all his nutrients from her bloodstream. He's living off her, quite literally. A parasite. Except he's also her reproductive partner. He's both parasite and mate, burden and benefit. From an evolutionary standpoint, this strategy makes a strange kind of sense. In the deep ocean, finding a mate is extremely difficult. The population density is low. The environment is vast. The chances of encountering another member of your species at exactly the right time for reproduction are very small. So anglerfish have evolved this extreme solution. When a male finds a female, he doesn't just mate with her and swim away hoping to find her again someday. No, he literally becomes part of her, permanently. This guarantees that when she's ready to reproduce, there will be sperm available. No need to search, no need to waste energy finding a mate. The mate is right there, attached, ready. But from a human perspective, it's deeply unsettling, isn't it? The male essentially gives up his entire individual existence to become a permanent appendage to the female. He loses his eyes, his ability to move, his independence, his organs, everything that makes him a separate, autonomous creature. He becomes nothing but a reproductive organ attached to someone else's body. It's a complete sacrifice of self, a total surrender of individuality in service of reproduction. And he doesn't have a choice in the matter, really. It's not a conscious decision. It's just biology, evolution, the way his species has adapted to the harsh realities of deep-sea life. It makes you think about relationships, doesn't it? About the balance between partnership and independence. About what we're willing to give up for connection, and what we need to keep for ourselves. Healthy relationships involve some degree of interdependence, of course. We connect with others. We rely on them. We allow ourselves to be vulnerable. But we also maintain our own identities, our own autonomy, our own sense of self. The male anglerfish loses all of that. He disappears completely into the relationship, becoming nothing but an organ of the female's body. And while this works for anglerfish, it's a successful evolutionary strategy for them. It's not exactly a model for human relationships. We need to maintain ourselves even as we connect with others. We need to keep our eyes, metaphorically speaking, keep our ability to move, to think independently, to exist as separate individuals even within relationships. Otherwise, we risk becoming just an appendage, just a function, losing ourselves completely in service of something else, whether that's a relationship, a job, a role, an identity that someone else has assigned to us. Fact 13. Zombie worms. Let's talk about death. Specifically, about what happens after death in the deep ocean. About the way life feeds on death. About the strange and often unsettling ways that energy and nutrients are recycled in the darkness of the abyss. When a whale dies near the surface, its body doesn't just disappear. A dead whale is an enormous package of nutrients, tons and tons of flesh, blubber, bone, and organ tissue. In the shallow ocean, where scavengers are plentiful, a whale carcass might be stripped clean in a matter of weeks or months. Sharks, fish, crabs, worms, they all come to feast. It's a feeding frenzy, a temporary bonanza of food in an ocean where food is often scarce. But when a whale dies and sinks to the deep ocean floor, something different happens. Something slower, something stranger. The body settles onto the seafloor, and immediately, it becomes an oasis. A whale fall, scientists call it. In an environment where food is rare and precious, a whale carcass represents more nutrition than most deep-sea creatures will encounter in their entire lives. The first scavengers to arrive are usually the mobile ones. Hagfish, sleeper sharks, crabs, anything that can detect the chemical signals of the carcass and move toward it. They tear into the soft tissues, the flesh and blubber, gorging themselves. This stage can last for months, even years for a large whale. But eventually, all the soft tissue is gone. What remains is a skeleton. Massive bones, still containing nutrients, fats, proteins, minerals, but locked away inside solid bone, inaccessible to most creatures. This is where things get really interesting, because there's a group of organisms that have evolved specifically to feed on whale bones. And they do it in one of the strangest, most unsettling ways imaginable. They're called ostacs. The name means bone devourer in Latin, but they're also known by another, more evocative name, zombie worms. These worms are bizarre creatures. They're small, usually just an inch or two long, and they look like tiny feathery plants more than animals. They have a crown of delicate, red plumes at one end that wave gently in the water, like the petals of an underwater flower. But here's what makes them truly strange. They have no mouth, no digestive tract, no stomach, no anus, no opening of any kind for food to enter or waste to exit. So how do they eat? How do they get nutrients from the whale bones? The answer is as ingenious as it is disturbing. They drill into the bone. The part of the worm you can see, those feathery red plumes, is just the tip. The rest of the worm extends down into the bone itself. The worm has root-like structures that penetrate deep into the bone, branching and spreading through the porous interior. And these roots secrete acid, bone-dissolving acid. The worm essentially melts the bone around its roots, breaking down the solid calcium and phosphate structure, dissolving it into a liquid that can be absorbed. Inside the bone, there's marrow, fatty, protein-rich tissue that's incredibly nutritious. As the worm's acid dissolves the bone, it releases this marrow, along with the fats and oils that whales store in their bones. And the worm absorbs it directly through its roots. But the worm can't do this alone. Like the tube worms at hydrothermal vents, ostax worms have a symbiotic relationship with bacteria. The worm's roots are packed with bacteria, millions upon millions of them, and these bacteria do most of the actual work of breaking down the dissolved bone material and converting it into nutrients the worm can use. So you have this strange, three-way relationship. The dead whale provides the raw material, the bacteria break it down and convert it into usable nutrients, and the worm provides a home for the bacteria and reaps the benefits of their work. It's a slow process. Ostax worms can live for years, decades even, gradually hollowing out the whale bones from the inside. If you were to cut open a whale bone that's been colonized by ostax, you'd see it riddled with holes and tunnels, like a honeycomb or a piece of Swiss cheese. The worms have literally eaten it from within, turning solid bone into a fragile, porous structure. Eventually, after decades or even centuries, the entire whale skeleton is consumed. Every last bit of nutrition has been extracted, recycled, converted from death into life. The whale that died and sank to the seafloor has been transformed into generations of worms, bacteria, and all the other creatures that fed on the carcass. It's the ultimate recycling program. Nothing is wasted. Even the bones, the hardest, most durable part of the animal, are eventually broken down and returned to the ecosystem. There's something both beautiful and horrifying about this, isn't it? Beautiful because it shows how life persists, how energy and nutrients are passed from one organism to another, how death feeds life in an endless cycle. Nothing is truly lost. Everything is transformed. But also horrifying because of the method. Acid-secreting worms with no mouths, boring into bone, melting it from the inside, feeding on marrow like something out of a gothic horror story. Zombie worms. The name fits. And yet, they're just doing what they evolved to do. They're not malicious. They're not evil. They're just organisms filling a niche, exploiting a resource that nothing else can access. In the deep ocean, where food is so scarce, the ability to feed on whale bones, a resource that's rare but incredibly rich when you find it, is a tremendous evolutionary advantage. Scientists estimate that there might be thousands of whale carcasses on the ocean floor at any given time, in various stages of decomposition. And each one becomes a mini ecosystem, supporting dozens or hundreds of species, some of which are found nowhere else. Some ostax species, in fact, are specialists. They only live on whale bones. Nowhere else. That's their entire habitat, their entire world. It makes you think about how life finds a way, doesn't it? Even in the strangest, most unlikely circumstances, even feeding on resources that seem impossible to access. Life adapts. Life persists. Life finds a niche and fills it. And it makes you think about death, about what happens after we're gone. We tend to think of death as an ending, as a full stop. But in nature, death is just a transformation, a transition, the end of one form of organization and the beginning of another. The whale's death becomes the worm's life. The bone becomes food. The ending becomes a beginning. Nothing is wasted. Nothing is truly lost. Everything continues, just in a different form. There's something comforting about that, perhaps. The idea that we're all part of a larger cycle. That when our own story ends, the matter and energy that made us up doesn't just disappear. It continues, transformed, recycled, part of something else. We're all made of recycled star stuff, as Carl Sagan famously said. The atoms in your body were forged in the hearts of ancient stars, billions of years ago. They've been part of countless other organisms before you. And after you, they'll be part of countless organisms to come. You're not separate from nature, from the cycle of life and death and rebirth. You're part of it, intimately, inextricably part of it. And there's a strange peace in accepting that. Fact 14. The 3-year pregnancy. Let's talk about time. About patience. About the strange ways that life in the deep ocean operates on a completely different schedule than life on land or in shallow water. We're used to thinking of pregnancy in terms of months. For humans, it's 9 months, 40 weeks, give or take. For dogs, it's about 2 months. Cats, about the same. Elephants, the longest land animal pregnancy we know of, carry their young for about 22 months, nearly 2 years. That seems incredibly long to us. We marvel at the patience of elephant mothers, carrying that weight, that life, for almost 2 years before giving birth. But in the deep ocean, there's a creature that makes elephant pregnancies look quick by comparison. It's called the frilled shark, and it's one of the most primitive, ancient-looking creatures still alive today. Scientists sometimes call it a living fossil, because it looks remarkably similar to sharks that lived hundreds of millions of years ago. It's changed very little over evolutionary time, maintaining its ancient form while the world above transformed again and again. The frilled shark doesn't look much like the sharks we're familiar with. It's more eel-like, with an elongated, serpentine body that can grow to 6 or 7 feet long. Its fins are small and set far back on its body, giving it that eel-like appearance. Its skin is dark brown or grey, almost black in the deep water where it lives. But the most striking thing about the frilled shark is its mouth. Open its jaws and you'll see row upon row of teeth, about 300 of them in all. And these aren't the triangular, serrated teeth of great whites or tiger sharks. These are needle-like teeth, thin and sharp, pointing backward. They look almost delicate, like pins, but they're wickedly effective at what they do. When a frilled shark catches prey, usually squid or small fish, those backward-pointing teeth make escape impossible. Anything that enters the mouth gets snagged on the teeth, and any attempt to pull away only drives the teeth deeper. It's like a fish trap, a one-way passage. Once something is in the frilled shark's mouth, it's not getting out. The frilled shark lives deep, usually between 400 and 4,000 feet down, in the dim twilight zone and the upper reaches of the midnight zone. It's rarely seen by humans. Most of what we know about it comes from specimens that have been caught accidentally in fishing nets, or that have washed up on beaches, usually sick or dying. But one thing scientists have learned about the frilled shark is truly remarkable. Its pregnancy lasts 3.5 years. 3.5 years. That's 42 months. Nearly 4 years from conception to birth. It's the longest gestation period of any vertebrate animal we know of. Longer than elephants. Longer than any whale. Longer than any other shark. Think about that for a moment. A female frilled shark becomes pregnant and then carries her developing young for 3.5 years before giving birth. During that time, human parents could conceive a child, carry it to term, give birth, watch that child learn to walk and talk, and start preschool. And the frilled shark would still be pregnant. Why so long? What takes 3.5 years? The answer lies in the harsh environment of the deep ocean. Remember, food is scarce down there. Energy is precious. The frilled shark has evolved to put enormous investment into each pregnancy, making sure that the young are as developed as possible before birth. Frilled sharks don't lay eggs like many other sharks. They're ovoviviparous, which means the eggs develop inside the mother's body. The embryos are nourished by yolk sacs initially, but they develop slowly, very slowly, over those 3.5 years. When they're finally born, when those 3.5 years are up, the baby frilled sharks emerge fully formed, relatively large, and capable of hunting on their own immediately. There's no helpless infant stage, no period of dependency. They're born ready to survive in the deep ocean, which is crucial in an environment where parental care is essentially non-existent. The mother doesn't stay with her young after birth. She can't afford to. She needs to start hunting again, building up her own energy reserves. The pups are on their own from the moment they're born. But because they've had 3.5 years to develop inside her, because she's invested so much time and energy into their gestation, they have a decent chance of survival. It's quality over quantity. A frilled shark might only reproduce a few times in her entire life. Maybe only 3 or 4 times, given how long each pregnancy takes. But the offspring she produces are well developed, with a reasonable chance of reaching adulthood themselves. Compare that to many fish that spawn thousands or millions of eggs at once, hoping that a tiny fraction, maybe 1 in a million, will survive to adulthood. The frilled shark takes the opposite approach. Fewer offspring, but much more investment in each one. There's something almost awe-inspiring about that level of commitment, isn't there? 3.5 years. Carrying that weight, that responsibility, that life developing slowly inside you. 3.5 years of swimming through the dark water, hunting for food, avoiding predators, all while pregnant. It requires patience on a scale we can barely imagine. Humans struggle with 9 months of pregnancy. We count down the weeks, eager for it to be over, for the baby to finally arrive. But 3.5 years? That's not pregnancy, that's a lifestyle. That's a state of being that extends across seasons, across years, across a significant portion of the shark's adult life. And yet the frilled shark does it. Not with impatience or complaint. She can't complain, of course, she's a shark. But she simply exists in that state, pregnant, for 3.5 years. Swimming through the darkness. Hunting. Surviving. Waiting for the right time. For the moment when those embryos are finally developed enough to be born. It's a reminder that different creatures operate on different timescales. What seems impossibly long to us is simply normal for them. The frilled shark isn't counting down the days, isn't frustrated by how long it's taking. Time moves differently in the deep ocean. Everything is slower. Growth is slower. Reproduction is slower. Life unfolds at its own pace, unhurried by the frantic rhythms of the surface world. Maybe there's something we can learn from that. We live in a world that's obsessed with speed, with efficiency, with getting things done quickly. We want instant results, instant gratification. We measure our progress in days and weeks, and if something takes months or years, we get frustrated. We want it to happen faster. But some things can't be rushed. Some things take time. Real significant time. 3.5 years' time. Whether it's healing from a deep wound, physical or emotional, or building something meaningful, or growing into the person you want to become. These things don't happen overnight. They don't happen in 9 months, either. Sometimes they take years. And that's okay. That's not a failure. That's just the natural timeline for that particular process. The frilled shark doesn't hurry her pregnancy. She can't. It takes the time it takes. And at the end of those 3.5 years, something viable emerges. Something that has a real chance of survival. Because it was given the time it needed to develop properly. Fact 15. The phantom jellyfish. There are creatures in the ocean so rarely seen that they're more myth than reality to most people. Creatures that exist at the very edge of our knowledge, glimpsed only a handful of times, known more from blurry photographs and brief video clips than from any detailed study. The deep ocean is full of these phantoms, these barely known creatures that drift through the darkness, living their entire lives unseen by human eyes. And one of the most spectacular, most mysterious of these phantoms is a jellyfish with the perfect name, Stygiomedusa gigantea. The name alone tells you something about it. Stygio, from Styx, the river in Greek mythology that separated the world of the living from the world of the dead. The river that souls crossed when they died, entering the underworld. It's a river of shadows, of darkness, of the boundary between life and death. And Medusa, well, that's the scientific term for jellyfish, but it also calls to mind the mythological Medusa, the gorgon with snakes for hair whose gaze could turn people to stone. Something beautiful and terrible at the same time. And gigantea, giant, because this jellyfish is indeed giant. One of the largest jellyfish in the world, though we've seen it so rarely that we're not entirely sure how large they can grow. The specimens that have been observed have bells, the main body of the jellyfish, that are over 3 feet in diameter. 3 feet. That's as wide as some people are tall. A dome of dark, translucent flesh, pulsing slowly through the water. But the bell isn't the most striking thing about Stygiomedusa. It's the arms. Or rather, the mouth arms. Most jellyfish have tentacles, thin, trailing appendages covered in stinging cells that they use to capture prey. But Stygiomedusa has something different. It has 4 thick, ribbon-like arms that extend down from its mouth, and these arms can be astonishingly long. 33 feet long, in some specimens. 33 feet. That's as long as a school bus. Imagine a jellyfish with a 3-foot-wide bell and arms that trail down for 33 feet below it. These arms don't look like tentacles. They look like flowing black ribbons, or veils, or perhaps kelp fronds, undulating slowly in the current. They're dark, almost black, and they move with a hypnotic, graceful motion, swaying and rippling as the jellyfish pulses through the water. If you were to see one from a submersible, it would look almost like a ghost. A phantom draped in flowing black cloth, drifting through the darkness. And that's assuming you could see it at all. Stygiomedusa lives deep, typically between 2,000 and 4,000 feet down, well into the midnight zone. It's been spotted off the coasts of several continents, so it seems to have a wide range, but encounters are extraordinarily rare. The first confirmed sighting was in 1899, more than a century ago, and since then, there have only been a few dozen confirmed observations. A few dozen, in over 120 years. For comparison, scientists have logged thousands of sightings of many other deep-sea species in that same time period. Stygiomedusa is a true phantom. It appears occasionally, briefly, in the lights of a research submersible or a remotely operated vehicle, and then it drifts away into the darkness, disappearing as mysteriously as it appeared. Because it's so rarely seen, we know very little about it. We don't know exactly what it eats, though scientists suspect it uses those long mouth arms to entangle prey, probably small fish or other jellyfish. The prey would get wrapped in those ribbon-like arms, held against the jellyfish's mouth until it could be consumed. We don't know how it reproduces, or how long it lives, or how many of them there are in the ocean. We don't know if it's rare because its population is small, or if it's just very good at avoiding detection. The ocean is vast and deep, and submersible expeditions are limited. Maybe there are thousands of Stygiomedusa drifting through the deep ocean right now, and we simply haven't found them because we haven't looked in the right places at the right times. Or maybe they really are rare. Maybe they're a species that exists at low population density, scattered thinly across the abyssal zones of the world's oceans, each individual drifting alone through vast stretches of empty water, rarely encountering even others of their own kind. It's impossible to know, really. And there's something almost beautiful about that uncertainty. In an age where we can track animals with GPS tags, where we can monitor populations with satellites and drones, where we have cameras and sensors scattered across the globe, there's still a creature that remains essentially unknown. Still a phantom that appears and disappears on its own terms, refusing to be fully catalogued or understood. Every time a research team spots a Stygiomedusa, it's an event. Footage gets shared among marine biologists. Articles get written. Because it's that rare. That special. Each sighting adds a tiny bit more to our understanding. but the picture remains incomplete. The phantom retains its mystery. There's something haunting about imagining it, isn't there? This enormous jellyfish, 3 feet wide, with 33 feet of dark ribbon arms trailing below, drifting through absolute blackness. No light, no sound, just the slow pulse of its bell, the gentle undulation of its arms, the patient movement through water that hasn't seen sunlight in millions of years. It doesn't know we're looking for it. It doesn't know it's rare or mysterious, or that scientists celebrate every sighting. It simply exists, following whatever instincts and behaviors jellyfish follow, living its life in the deep darkness, occasionally catching prey in its flowing arms, occasionally encountering another of its kind. Maybe it's better that we don't know everything about it. Maybe some creatures should remain mysterious, should retain that quality of the unknown. Maybe the Stygia medusa, drifting through the Stygian darkness of the deep ocean, should remain at least partly a phantom, at least partly a mystery. We don't need to know everything. We don't need to catalogue and tag and track every creature. Some things can exist beyond the reach of our knowledge, in the places we can't easily get to, living lives we can't fully observe or understand. And maybe that's true for us too. Maybe there are parts of ourselves that should remain mysterious, even to us. Depths we haven't fully explored, aspects of our own nature that we haven't fully catalogued or understood. And maybe that's okay. Maybe that's even good. You don't need to have yourself completely figured out. You don't need to shine a light into every corner of your psyche, understand every motivation, explain every feeling. Some things can remain in the deep, in the dark, mysterious, and unexplored. You're allowed to be a bit of a phantom to yourself, to drift through your own internal darkness occasionally, uncertain, mysterious, not fully known. That's not a failure. That's just being human, being complex, being as deep and vast and incompletely explored as the ocean itself. Fact 16. The Stargazer's Trap. Let's talk about patience, about the art of waiting, about creatures that have perfected the strategy of lying perfectly still, concealed, ready to strike at a moment's notice. There's a type of fish that embodies this strategy perfectly, and it has one of the most evocative names in the ocean, the stargazer. The name sounds almost poetic, doesn't it? Romantic. A stargazer. Someone who looks up at the night sky, contemplating the cosmos, dreaming, wondering about the mysteries of the universe. But the stargazer fish is not romantic. It's not dreaming. It's not wondering about the cosmos. It's lying in wait, buried in sand, with only its face exposed, staring upward. Not at stars, but at prey. Stargazers are ambush predators, and they've evolved some of the most effective and most disturbing hunting adaptations in the ocean. Let's start with the basics. Stargazers are bottom-dwelling fish, usually found in sandy or muddy areas in relatively shallow water, though some species live deeper. They have large, flat heads with eyes positioned on top, pointing upward. Their mouths are also on top of their heads, facing upward. Essentially, their entire face points up toward the surface. This unusual anatomy makes perfect sense when you understand their hunting strategy. The stargazer buries itself in the sand, using its fins to dig down and cover itself completely except for its eyes and mouth. It's remarkably good at this. In a matter of seconds, a stargazer can disappear into the sand, becoming essentially invisible. Once buried, it waits, perfectly still, perfectly patient. Its eyes, positioned to look upward, scan the water above for movement. Small fish, crustaceans, anything edible that swims overhead. And when something does swim overhead, when prey comes within range, the stargazer strikes. Its attack is explosive, incredibly fast. It bursts upward out of the sand, its large mouth opening wide, creating suction that pulls the prey in. The attack happens in a fraction of a second. The prey often doesn't even see it coming. One moment swimming along normally, the next moment engulfed by a mouth that appeared from nowhere. But the stargazer has other tricks up its sleeve, or rather, in its biology, because it's not just waiting to bite. It has additional weapons that make it one of the most dangerous fish for its size. First, there are the venomous spines. Stargazers have spines behind their gills, and sometimes on other parts of their body that contain venom. If something or someone touches or grabs a stargazer, those spines can deliver a painful sting. The venom isn't usually fatal to humans, but it's extremely painful, causing intense localized pain that can last for hours or even days. Divers and fishermen who've accidentally stepped on or handled stargazers describe the pain as excruciating, like being stabbed with a hot poker. The affected area swells, throbs, burns. It's a defense mechanism, of course, a way to discourage predators from eating the stargazer. But it's also a hazard for any prey that manages to struggle after being caught. But here's where it gets really interesting. Some species of stargazer can also generate electricity. That's right, electric shocks. Like an electric eel, but in fish form, buried in the sand, waiting with its face pointing up. The stargazer has specialized organs near its eyes that can produce electrical discharges. Up to 50 volts in some species. 50 volts. That's enough to give a substantial shock to anything that touches it or comes very close. It's not enough to kill a large animal or a human, but it's definitely enough to stun, disorient, or paralyze prey. Scientists believe the stargazer uses these electric shocks in two ways. First, as a defensive weapon, like the venom, something to discourage predators. But second, and more importantly, as a hunting tool. When the stargazer strikes at prey, it can deliver an electric shock at the same time, momentarily stunning or paralyzing the prey, making it easier to swallow. Imagine being a small fish, swimming along near the sandy bottom. You don't see any danger. The bottom looks empty, peaceful, normal. And then suddenly, in a fraction of a second, the sand explodes upward. A huge mouth appears. You're hit with an electric shock that stuns your nervous system. Venomous spines threaten from multiple directions, and before you can even process what's happening, you're being swallowed. It's the perfect ambush predator setup. Multiple weapons, perfect camouflage, explosive speed, and the patience to wait for just the right moment. That patience is really the key, isn't it? The stargazer doesn't chase prey. It doesn't actively hunt. It doesn't even move around much once it's found a good spot. It just waits, buried in sand, motionless, for hours possibly, maybe even days if necessary, just waiting, watching, ready. And when the moment comes, when prey swims overhead at just the right distance, just the right angle, then, and only then, does it act. And when it acts with total commitment, total explosiveness, total focus. No hesitation, just pure, decisive action. There's something almost zen about it, in a way. This perfect stillness, this perfect patience, followed by this moment of explosive action. The stargazer isn't anxious while it waits. It isn't fidgeting or worrying about whether prey will come. It's just waiting, present, still, alert. We humans aren't very good at waiting, are we? We get impatient. We fidget. We check our phones. We wonder when something is going to happen. We worry that it won't happen. We get frustrated by the delay. But the stargazer teaches a different way. Wait with perfect stillness, perfect patience. And when the moment comes, and it will come, eventually, act with total commitment and decisiveness. Of course, we're not ambush predators waiting to shock and devour prey. But maybe there's still something to learn from that approach. Sometimes in life, the best thing to do is wait. Be patient. Stay still. Stay alert. But don't force things. Don't thrash around trying to make something happen before it's ready. And then when the moment is right, when the opportunity appears, when the time comes to act, then you move. Decisively. Fully. Without hesitation. Fact 17. The vampire squid. There are names that sound terrifying, and then there's the name of the creature we're about to discuss. A name so dramatic, so evocative of darkness and evil, that it sounds like it came from a gothic horror novel rather than a scientific classification. Vampirotuthis infinalis. Let's break that down. Vampirotuthis, vampire squid, and infinalis, from hell. Put it together and you get vampire squid from hell. That's not a nickname. That's not something sensationalist journalists made up. That's its actual scientific name, the formal Latin designation that scientists use in academic papers. Vampire squid from hell. The name alone tells you that whoever discovered and named this creature was deeply impressed, or perhaps deeply unsettled, by what they found. And when you see a vampire squid, you understand why. It's not large, usually only about 6 inches long, though some can grow up to a foot. But what it lacks in size, it makes up for in sheer strangeness and disturbing appearance. The vampire squid is dark. Very dark. Deep red or black, depending on the light. Its body is covered with light-producing organs called photophores that glow with a bioluminescent light, giving it an eerie, otherworldly appearance in the darkness. The eyes are disproportionately large, the largest eyes relative to body size of any animal in the world. Huge, dark, unblinking eyes that seem to stare into your soul. But the most unsettling feature is what happens when the vampire squid feels threatened. Most squid have 8 arms and 2 longer tentacles. The vampire squid has 8 arms, but they're connected by a web of skin, like a cape or a cloak. And when threatened, it can pull this cloak up and over itself, essentially turning itself inside out. When it does this, the inside of the cloak is revealed, and that's where you see the fangs. Not actual fangs, but rows of soft, fleshy spines called cirri that line the inside of the cloak. They look like teeth, or thorns, or the spines of some alien creature. The vampire squid pulls its cloak over itself, becoming a ball of darkness covered in these spine-like projections, with those enormous eyes still visible, staring out from within. It's a defensive posture, designed to make the vampire squid look larger and more threatening to potential predators. And it works. It looks absolutely terrifying, like something that crawled out of a nightmare. The name vampire squid also comes from the fact that, historically, scientists thought it fed on live prey, sucking fluids from victims like a vampire. But it turns out that's not true. The vampire squid isn't a predator at all. It doesn't hunt. It doesn't attack. Despite its terrifying name and appearance, it's actually one of the more peaceful deep-sea creatures. Instead of hunting, the vampire squid feeds on marine snow. We've mentioned marine snow before. That constant rain of organic material falling from the surface. Dead plankton, feces, mucus, bits of decomposing animals. It drifts down through the water column like snowflakes, settling slowly toward the seafloor. Most creatures in the deep ocean rely on marine snow to some extent, but the vampire squid has specialized in it. It has 2 long, retractable filaments, different from its arms, that it extends out into the water. These filaments are covered in sticky mucus, and they act like nets, catching particles of marine snow as they drift past. Once the filaments have collected enough material, the vampire squid retracts them and uses its arms to scrape off the collected particles, bringing them to its mouth. It's a slow, methodical feeding process. No chasing prey, no violent attacks, just patient collection of falling debris. So despite its name, despite its appearance, the vampire squid is actually a gentle detritivore, feeding on the remains of things that have already died. It's not a monster. It's a janitor, really. A recycler, playing an important role in the deep-sea ecosystem by consuming and processing the organic material that falls from above. But the name stuck. Vampire squid from hell. Because sometimes, in nature, appearances matter more than behavior. Sometimes, looking terrifying is enough to earn a terrifying name, even if you're actually quite harmless. There's something almost sad about that, isn't it? Being judged entirely on how you look rather than on what you do. The vampire squid, drifting through the darkness, peacefully collecting marine snow, burdened with this dramatic, frightening name because of its appearance and defensive display. We do this to each other sometimes, don't we? Judge based on appearances. Make assumptions about people based on how they look, how they dress, how they present themselves to the world. We see someone who looks intimidating, who has a scary exterior, and we assume they must be dangerous, must be cruel, must be something to avoid. But often, beneath that exterior, there's something much softer, much gentler, maybe even something quite beautiful, in its own way. The vampire squid, with its cloak of spines and its enormous eyes, is actually just trying to survive in one of the harshest environments on Earth. It's not attacking anyone. It's just collecting falling debris and trying to get enough nutrition to stay alive. Sometimes the things that look most frightening are actually the most harmless. And sometimes the things that look harmless, the things that seem gentle and soft and non-threatening, those can be the real dangers. Appearances can deceive in both directions. But here's another thought. Maybe the vampire squid doesn't care what we call it. It doesn't know its scientific name. It doesn't know that humans have labeled it the vampire squid from hell. It just exists, doing what vampire squid do, living its life in the deep darkness, feeding on marine snow, occasionally pulling its cloak up when something threatens it. Names are human constructions. Labels are human constructions. The vampire squid is just itself, regardless of what we call it. And maybe that's true for all of us. Maybe we're all just ourselves, regardless of the names and labels that get applied to us. Regardless of how others perceive us, or judge us, or classify us. You can be called something. You can be labeled, categorized, named, and yet still be something entirely different underneath. The labels don't define you. The names don't capture your essence. You're more complex, more nuanced, more mysterious than any name could convey. Fact 18. Marine snow. Let's talk about something that sounds beautiful, but is actually quite disturbing when you think about it. Something that has a poetic name, but a rather grotesque reality. Marine snow. The name conjures up something lovely, doesn't it? Snow. We think of snowflakes drifting down on a winter day, white and pure and crystalline. We think of the peaceful silence of a snowfall, the way it blankets everything in soft white. Snow is beautiful. Snow is clean. Snow is something children play in, something we associate with holidays and wonder and magic. Marine snow sounds like it should be equally beautiful. Perhaps some kind of underwater phenomenon, some kind of magical underwater snowfall, white particles drifting down through blue-green water, creating an enchanted scene like something from a fairy tale. But marine snow is not that. Marine snow is not beautiful, at least not in the conventional sense. Marine snow is, quite literally, a constant rain of death and waste falling from the sunlit waters above down into the darkness below. Let's be very clear about what marine snow actually consists of. It's dead organisms, plankton that have died and are sinking. It's fecal matter, the waste products of fish, whales, and countless other marine animals. It's mucus, the slimy secretions that many marine organisms produce. It's bits of decomposing flesh from larger animals. It's pieces of plants and algae, breaking down as they sink. It's the shed skins and shells of creatures molting and growing. It's organic debris, detritus, the leftovers of life in the sunlit zone, falling like snow through the water column, drifting down toward the seafloor. If you were to be in a submersible in the deep ocean, you would see it. Particles of various sizes, drifting down through the cone of your lights. Some as small as dust motes, some as large as your fist, all falling, constantly, endlessly, like a slow-motion snowstorm that never stops. This is the primary food source for most life in the deep ocean. This rain of death and waste. This is what sustains the ecosystem down there. Without marine snow, the deep ocean would be essentially lifeless. There's no photosynthesis in the darkness, remember. No plants, no algae, no primary producers creating food from sunlight. The only source of organic material, of energy, of nutrition, is what falls from above. So everything in the deep, from the tiniest bacteria to the largest fish, depends on this constant rain of debris. They're all connected to the surface world by this falling snow, this umbilical cord of dead matter connecting the sunlit zone to the abyss. The amount of marine snow that falls varies depending on how productive the surface waters are. In areas where there's lots of plankton, lots of life, there's more marine snow. In areas where the surface is less productive, there's less. But it's always falling. Always. 24 hours a day, 7 days a week, year after year, decade after decade, century after century. This slow rain of organic particles, drifting down through the darkness. And it falls slowly. Very slowly. A single particle might take days, weeks, even months to make the journey from the surface to the abyssal seafloor. As it falls, organisms feed on it, breaking it down. Bacteria colonize it. Tiny zooplankton nibble at it. Small fish eat it. Larger fish eat those fish. And on, a food chain built on falling debris. By the time marine snow reaches the deepest parts of the ocean, it's been picked over and reprocessed many times. What finally settles on the seafloor is the stuff that nobody else wanted. The hardest to digest, the least nutritious, the most resistant to decomposition. And even that gets consumed, eventually, by worms and bacteria and other detritivores living in the sediment. Nothing is wasted. Nothing goes unused. Every particle, no matter how small or how depleted of nutrition, eventually becomes food for something. It's the ultimate recycling system, far more efficient than anything humans have created. There's something both beautiful and disturbing about this, isn't there? Beautiful because it shows how interconnected everything is, how the death of organisms in one part of the ocean feeds life in another part. The great cycles of life and death, of consumption and recycling, playing out on a massive scale. But also disturbing because it's so visceral. We're not talking about some abstract concept of recycling. We're talking about feces and mucus and rotting flesh, falling through the water, being eaten by creatures that have no other choice. It's survival at its most basic, most unglamorous level. And yet, the creatures that live on marine snow don't find it disgusting. They don't wish they had fresher food, better food. They've evolved to thrive on this diet. To them, a rich concentration of marine snow is like a feast. It's everything they need. It's life itself. It reminds us that concepts like disgusting or waste are human constructions. In nature, there's no waste. There's only resources in different forms. What's waste to one organism is food to another. What seems disgusting to us is life-giving to something else. And in the deep ocean, where food is so scarce, where energy is so precious, there's no room for being picky. You eat what's available. You consume what falls from above, regardless of what it is or where it came from. You take what you can get, and you survive on it. There's a kind of humility in that, isn't there? An acceptance of reality as it is, not as you might wish it to be. The deep-sea creatures don't complain about their food source. They don't long for fresh plankton or live prey. They simply take what comes, what falls into their reach, and they make it work. Maybe there's a lesson there for us. We spend so much time wishing things were different. Wishing we had better circumstances, better resources, better opportunities. We look at what we have, the equivalent of marine snow in our own lives, and we think, this isn't good enough. This isn't what I wanted. This is just leftovers, just scraps, just the stuff nobody else wanted. But maybe the question is, can we survive on it? Can we make use of it? Can we extract nutrition and energy and life from what's available, even if it's not what we'd prefer? The deep-sea creatures do this constantly. They take the scraps, the leftovers, the stuff that's been falling through the water for weeks, picked over by everyone else, and they make it enough. They make it work. They survive, and sometimes even thrive, on what most other creatures would consider inadequate. That's resilience. That's adaptability. That's the ability to work with what you have rather than waiting for what you wish you had. Fact 19. The immortal jellyfish. Let's end with something that challenges one of the fundamental rules we think we know about life. Something that defies what we believe about aging, about death, about the inevitable progression from birth to death that governs every living thing. There's a jellyfish, a tiny jellyfish, smaller than a fingernail, that can theoretically live forever. It's called Turritopsis dornii, and it's been nicknamed the immortal jellyfish. And that's not hyperbole. That's not an exaggeration. This jellyfish has the ability to reverse its aging process and revert to a juvenile state, essentially restarting its life cycle. Over and over again, potentially forever. Let's understand how this works. Most jellyfish, in fact most animals, have a life cycle that goes in one direction. You're born, you grow, you mature, you reproduce, you age, you die. That's the pattern. That's the rule. You might live for a few days or for 100 years, but the direction is always the same. forward, toward death. There's no going back. But Turritopsis dohrnii can go back. When this jellyfish reaches sexual maturity, when it's an adult, fully formed, with all its tentacles and its bell and its reproductive organs, it has an unusual ability. If it becomes stressed, if it's injured, if it's starving, if environmental conditions become harsh, or even if it's just old, it can trigger a transformation. The adult jellyfish settles to the seafloor. Its bell and tentacles begin to resorb, literally reabsorbing back into its body. It transforms into a blob-like mass of cells called a cyst. And then, from that mass, new polyps emerge. Polyps are the juvenile stage of a jellyfish, tiny, stationary, stalk-like structures that attach to surfaces and bud off baby jellyfish. Essentially, the adult jellyfish reverts to being a baby again. It goes backward through its life cycle, transforming from adult to juvenile, from mature to immature, from old to young. And then the process starts over. The polyps mature into new adult jellyfish, which can then repeat the process if necessary, over and over again, potentially forever. It's as if a butterfly could, when threatened or old, transform back into a caterpillar. Or as if a human, upon reaching old age, could revert to being a toddler and start growing up all over again, retaining no memory of their previous life, but having their cells completely renewed and refreshed. It sounds like science fiction. It sounds impossible. But Turritopsis dohrnii does it. Scientists have observed this transformation in laboratories. They've watched adult jellyfish revert to polyps, and then mature again into adults. The process is real. It happens. The immortal jellyfish can, in theory, escape death indefinitely by repeatedly reverting to a younger state. Now, this doesn't mean that Turritopsis dohrnii is actually immortal in practice. Individual jellyfish still die all the time. They get eaten by predators. They succumb to disease. They get caught in unfavorable currents and die from stress or starvation before they can complete their transformation. Immortality, in theory, doesn't protect you from the hazards of daily life. But the potential is there. If a Turritopsis jellyfish could somehow avoid all predators, all diseases, all accidents, if it lived in perfect conditions, it could theoretically live forever, cycling through its life stages repeatedly, never truly dying of old age. It's one of the few organisms we know of that has defeated biological aging. Humans age, dogs age, trees age, even bacteria eventually die. But Turritopsis dohrnii has found a way around that fundamental rule. How does it do this? How does it reverse aging? The answer lies in a process called cellular transdifferentiation. In most organisms, once a cell has specialized, once it's become a skin cell or a muscle cell or a nerve cell, it stays that specialized type forever. That's what differentiation means. The cell has committed to a particular role and can't become something else. But in Turritopsis dohrnii, the cells can de-differentiate. They can go back to being unspecialized stem cells. And then they can differentiate again into something new. A muscle cell can become a nerve cell. A digestive cell can become a reproductive cell. The entire body can essentially reprogram itself, reorganizing its tissues, remaking itself from the cellular level up. It's a profound ability, and scientists are intensely interested in it. If we could understand exactly how Turritopsis does this, if we could figure out the molecular mechanisms that allow cellular transdifferentiation, it might have implications for human medicine. Could we someday regenerate damaged organs? Could we reverse aspects of aging? Could we reset our cells the way the immortal jellyfish does? We don't know. The research is still in early stages. But the fact that even one organism can do this, can reverse its aging, can restart its life, suggests that the rules we thought were absolute might be more flexible than we imagined. There's something both hopeful and unsettling about that, isn't it? Hopeful because it suggests that death and aging might not be as inevitable as we thought. That maybe, someday, we might find ways to extend life, to reverse damage, to give people second chances at youth. But also unsettling because it challenges our understanding of identity, of continuity, of what it means to be a particular individual. If the jellyfish reverts to a polyp, is it still the same jellyfish? Does it have any continuity of consciousness or memory? When it matures into an adult again, is it the same individual that went through the transformation, or is it essentially a new organism? These are philosophical questions that we can't really answer, but they're worth thinking about. What makes you you? Is it your body? Your cells? Your memories? Your consciousness? If all your cells were replaced, which actually happens naturally over time anyway, are you still the same person? The immortal jellyfish doesn't worry about these questions. It simply does what its biology allows it to do. When conditions warrant it, it transforms. It reverts. It starts over. No anxiety about losing its identity. No concern about whether it's still the same jellyfish. It just survives, using whatever tools evolution has given it. And maybe that's enough. Maybe survival, continuity of life. Even if not continuity of individual consciousness, maybe that's what matters. The pattern persists. The organism continues. Even if everything about it has changed, something essential remains. In a way, we do something similar, don't we? We're constantly changing, constantly transforming. The person you were 10 years ago, are you still that person? You've changed. Your cells have been replaced. Your thoughts have evolved. Your experiences have shaped you into something different. And yet, there's a continuity. There's a thread that connects your past self to your present self. You're not the same, but you're also not completely different. You're both. You're the continuity and the change, the persistence and the transformation, all at once. Maybe the immortal jellyfish, cycling through its life stages, is just doing more dramatically and more visibly what we all do more gradually and more subtly. We all transform. We all change. We all, in a sense, die and are reborn again and again throughout our lives. We just do it more slowly, without the dramatic transformation from adult to polyp and back again. Tonight, though, you don't need to think about transformation or immortality or the nature of identity. Tonight, you can simply rest in being who and what you are right now, in this moment. You don't need to revert to anything. You don't need to transform into anything. You don't need to become younger or older or different in any way. You can simply be exactly as you are right now. Your breathing is slow and steady. Your body is comfortable and relaxed. And you're drifting now gently into sleep. Not transforming. Not reverting. Just transitioning naturally and easily from wakefulness to sleep. From activity to rest. From consciousness to the deep, peaceful unconsciousness of sleep. This is a natural cycle, like the jellyfish's life cycle, but simpler. Wake and sleep. Wake and sleep. Day after day, year after year. A rhythm as old as life itself. Fact 20. Slingshot jaws. There are creatures in the deep ocean that seem designed specifically to haunt nightmares. Creatures whose appearance and hunting methods are so alien, so unsettling, that they don't seem like they should exist on Earth at all. They seem like they belong in science fiction, in horror movies, in the darkest corners of human imagination. The goblin shark is one of those creatures. If you've never seen a goblin shark, imagine this. A shark with a long, flat, blade-like snout projecting from its face like a sword. Pinkish-grey skin, almost translucent, giving it a ghostly, corpse-like appearance. Small eyes. And a mouth. Well, we'll get to the mouth in a moment, because that's where things get truly disturbing. Goblin sharks are rare. They live deep, typically between 890 and 3,150 feet down, though they've been found even deeper. They're occasionally caught by deep-sea fishing operations, usually by accident, and that's how we know most of what we know about them. They don't survive long when brought to the surface, so studying live goblin sharks is nearly impossible. But the specimens we've examined have revealed something extraordinary and deeply unsettling about how they feed. Most sharks have jaws that are relatively fixed to their skull. When they bite, they open their mouth, and the upper jaw might protrude slightly forward, but it's a relatively subtle movement. You're mostly just seeing the mouth open wider. But the goblin shark's jaw isn't fixed to its skull in the normal way. Instead, it's loosely attached, suspended by elastic ligaments that can stretch dramatically. And when the goblin shark detects prey, when it senses something edible in front of it. Those ligaments release like springs, and the entire jaw shoots forward out of the shark's face. We're not talking about a small protrusion. We're talking about the jaws extending several inches forward, catapulting out of the shark's head at incredible speed. In high-speed footage, it looks exactly like the creature from the movie Alien, when the inner mouth shoots forward to attack. It's the same mechanical principle, the same horrifying visual. One moment, you're looking at a shark with a relatively normal-looking mouth, tucked beneath that long blade snout. The next moment, the jaws have exploded forward, extending out toward the prey, teeth exposed, moving so fast that the prey has no time to react. The entire attack takes a fraction of a second. The jaws shoot forward, the teeth close on the prey, and then the jaws retract back into the normal position, pulling the captured prey into the shark's throat. It's over almost before it began. Blink and you'd miss it. Scientists call this slingshot feeding, and it's extremely rare in nature. A few other fish have protrusible jaws that can extend forward, but none quite like the goblin shark. None with that same explosive, spring-loaded, nightmare-inducing mechanism. Why did the goblin shark evolve this ability? What's the advantage? Remember, the goblin shark lives in the deep ocean, where prey is scarce and scattered. In an environment where food is rare, you can't afford to miss when you get a chance to eat. You can't afford to have prey escape because you weren't fast enough or your bite wasn't accurate. The slingshot jaw solves this problem. It allows the goblin shark to strike with incredible speed and precision. The shark doesn't even need to get that close to the prey. The extending jaws cover extra distance, reaching out to grab prey that might be just slightly out of reach of a normal bite. And because the movement is so fast, so explosive, prey doesn't have time to react or escape. One moment they're swimming in the darkness, unaware. The next moment, they're caught in jaws that appeared from nowhere, faster than their nervous system can even register the threat. It's an ambush predator's dream weapon, a biological spring-loaded trap attached to a face. That long, blade-like snout also plays a role in the hunting strategy. Scientists believe it's packed with electroreceptors, sensors that can detect the weak electrical fields produced by living organisms. The goblin shark swims slowly through the darkness, waving its snout back and forth like a metal detector, sensing for the electrical signature of prey. When it detects something, when those sensors pick up the telltale electrical field of a fish or squid nearby, the shark positions itself, and then snap. The jaws catapult forward. The prey is caught. The hunt is successful. It's an efficient system, perfectly adapted to the deep-sea environment. But it's also deeply unsettling to witness. There's something fundamentally disturbing about a jaw that can detach from a face and shoot forward. It violates our expectations about how bodies should work, how faces should be structured. We expect mouths to open and close, sure, but we don't expect them to extend outward, to launch themselves at prey like a biological projectile. It's too alien, too wrong, too much like something from a horror movie. And yet it's real. It's just biology, just evolution solving a problem in a creative, if unsettling way. The goblin shark isn't evil or monstrous. It's just hungry, and it's evolved an effective way to catch food in an environment where food is hard to come by. But still, those jaws, that movement, that moment when the mouth explodes forward out of the face, teeth bared, moving faster than you can track. It's nightmare fuel. Makes you grateful, doesn't it, that we don't live in the deep ocean? That we don't have to worry about creatures with spring-loaded jaws hunting us in the darkness? We have our own dangers, sure, but at least we don't have to contend with goblin sharks. The creatures of the deep live in a different world with different rules. A world where normal biology isn't quite enough, where standard equipment doesn't cut it. A world where you need special adaptations, unusual mechanisms, strange and unsettling solutions to survive. And the goblin shark, with its slingshot jaws, is perfectly suited to that world. Perfectly adapted. Perfectly deadly, in its own slow, patient, deep-sea way. But then in 2005, scientists finally identified the likely source of the bloop. It wasn't a creature at all. It was ice. Specifically, it was an icequake, a massive calving event where a huge section of ice breaks off from an Antarctic ice shelf or glacier and crashes into the ocean. When enormous chunks of ice, sometimes the size of entire buildings or even larger, break off and fall into the water, they create incredibly powerful sounds. The ice cracking, the splash, the underwater shockwaves, all of this generates enormous amounts of acoustic energy. And the pattern of the bloop, when analyzed carefully, matches the acoustic signature of ice calving events. The rising tone, the duration, the frequency distribution, it all fits. So the bloop wasn't a monster. It wasn't an unknown creature. It was ice. Huge amounts of ice breaking off from Antarctica and crashing into the Southern Ocean. Some people were disappointed by this explanation. They wanted the bloop to be something mysterious, something alive, something that proved there were still giant, unknown creatures in the ocean. The truth, that it was just ice, seemed mundane by comparison. But is it really mundane? Think about what it actually means. The bloop was caused by ice breaking off from Antarctica. Ice that's been frozen for thousands, maybe millions of years. Ice that's now melting, calving, disappearing into the ocean because the planet is warming. The bloop wasn't a monster, but it was still a kind of warning. A sound of the Earth changing. Of ice that used to be stable, now breaking apart. Of climate systems in flux. Of forces at work on a planetary scale. And the sheer power of the sound. The fact that ice breaking can create a noise loud enough to be heard 3,000 miles away. That's awe-inspiring in its own right. It reminds us how powerful natural forces are. How small we are in comparison. How much energy is involved in geological and climatic processes. Even now, knowing what caused the bloop, there's something deeply unsettling about listening to the recording. That rising, blooping sound, knowing it represents millions of tons of ice breaking off and crashing into the ocean. Knowing that this is happening more and more frequently as the planet warms. Knowing that there are forces at work in the world that we can barely comprehend. Forces that generate sounds loud enough to echo across entire oceans. The ocean is full of these sounds. These booms and cracks and rumbles and hums. Most of them we never hear, never even know about. But they're happening all the time, all around the world. The Earth groaning and shifting and changing, producing a constant acoustic backdrop that plays out in the depths. And sometimes, when we listen carefully, we catch just a fragment of it. Just a brief recording of something vast and powerful happening somewhere in the deep. And even when we figure out what it is, even when we solve the mystery, it still leaves us with a sense of awe. A sense of how much is happening that we don't see, don't hear, don't experience directly. The bloop is no longer a mystery, but the ocean still holds many mysteries. Many sounds we haven't identified. Many phenomena we don't fully understand. The deep ocean is still, in many ways, as alien and unknown as the surface of Mars. And that's okay. That's even good. We don't need to solve every mystery. We don't need to explain every sound. Some things can remain unknown, at least for a while, reminding us that the world is larger and stranger than we can fully grasp. Fact 22, the upsweep. We're not done with mysterious ocean sounds yet. Because while the bloop has been explained, there are other sounds, equally strange, equally mysterious, that remain unexplained to this day. One of the most fascinating of these is called the upsweep. Since 1991, for over 30 years now, underwater listening stations in the Pacific Ocean have been detecting a sound. A strange, haunting sound that occurs seasonally, primarily in the spring and fall. It's a long, rising tone, like a wail or a moan, that sweeps upward in frequency. Hence the name, the upsweep. When you listen to a recording of the upsweep, and you can find them online if you're curious, it sounds almost musical, almost like an instrument being played underwater. A low moan that rises and falls, in a slow rhythmic pattern. It's oddly beautiful, in an eerie sort of way. Haunting, melancholic. But here's what makes it truly mysterious. The sound is loud enough to be detected across the entire Pacific Ocean. Every listening station in the Pacific picks it up when it's active. We're talking about a sound that propagates across thousands upon thousands of miles of water. A sound that fills an entire ocean basin. And we don't know what causes it. Scientists have been studying the upsweep for decades now. They've analyzed its frequency patterns, its seasonal variations, its intensity fluctuations. They've compared it to known sound sources: whales, seismic activity, underwater volcanoes, human activities. And they haven't found a definitive match. Some scientists think it might be related to underwater volcanic activity. There are several underwater volcanoes in the Pacific, and volcanic activity can create low-frequency sounds that propagate through water very efficiently. The sound might be coming from magma moving beneath the seafloor, or from hydrothermal vents, or from volcanic gases escaping through cracks in the ocean floor. This is the leading theory, and it's probably correct. The location where the upsweep seems loudest, the area in the Pacific where the sound appears to originate, coincides with a region of volcanic activity. So volcanic processes are likely involved somehow. But here's the thing, we haven't been able to pinpoint the exact source or mechanism. We haven't actually observed what's creating the sound. We can make educated guesses based on the characteristics of the sound and the geology of the region, but we don't have definitive proof. The upsweep remains, technically, unexplained. And there's something else that makes it even more mysterious. The sound has been getting quieter over the years. When it was first detected in 1991, it was much louder than it is now. Each year, it seems to decrease slightly in intensity. Scientists aren't sure why. Is the volcanic activity that's creating it winding down? Is the source moving? Is something else happening? We don't know. And that uncertainty, that mystery, makes the upsweep all the more fascinating. Imagine it. Right now, as you lie here listening to these words, there's a sound in the Pacific Ocean. A low, rising moan, sweeping upward in frequency, loud enough to be heard across thousands of miles. It's been happening since before many people listening to this were even born. It's been going on for decades, this constant, rhythmic wailing in the deep. And the ocean carries that sound, propagates it, lets it travel vast distances through the water. Any whale swimming in the Pacific might hear it. Any submarine passing through those waters would detect it on their sonar. It's there, always, a background hum of the ocean, a voice of the deep speaking in tones we don't fully understand. There's something almost cosmic about that, isn't there? This planet-scale sound, this oceanic voice, speaking continuously in the depths. Not trying to communicate with us. It probably has nothing to do with us at all. Just existing. Just sounding. Just being part of the vast, ongoing symphony of natural processes that make up the Earth. We humans tend to think that if something is happening, it must be for a reason. It must be trying to tell us something. We look for meaning, for purpose, for communication in natural phenomena. But sometimes things just are. Sometimes sounds occur, not to send a message, but simply as a byproduct of natural processes. Volcanoes erupt. Magma moves. Gases escape. And these processes create sounds as a side effect, not as a goal. The upsweep doesn't care if we hear it or understand it. It's not for us. It's just part of the Earth being the Earth, doing what it does, creating sounds and movements and changes that we happen to be able to detect with our technology. And yet we listen. We record. We analyze. We give it a name, the upsweep, and we try to understand it. Because that's what humans do. We're curious. We want to know. We want to solve mysteries, to understand the world around us. But maybe it's okay if some mysteries remain unsolved, at least for a while. Maybe it's okay to simply know that the upsweep exists, that it's out there, making its strange music in the depths of the Pacific, without needing to fully understand every detail of its origin. Maybe we can appreciate the mystery, appreciate the strangeness, appreciate the fact that the Earth is still capable of surprising us, of doing things we don't entirely understand. Fact 23. The 52 Hz whale. Let's talk about loneliness, about isolation, about what it means to call out into the darkness and receive no answer. There's a whale in the ocean, somewhere in the Pacific, that has been swimming alone for decades. Scientists have been tracking its movements since 1989, listening to its calls, following its migrations across thousands of miles of open water. They call it the 52 Hz whale, named after the frequency at which it sings. And it's earned another name, one that's both poetic and heartbreaking: the loneliest whale in the world. Here's why. Most baleen whales, the large whales like blue whales, fin whales, humpback whales, communicate at frequencies between 15 and 25 Hz. These are very low frequencies, below the range of human hearing. Whale songs at these frequencies can travel hundreds of miles through the ocean, allowing whales to communicate across vast distances. But the 52 Hz whale sings at 52 Hz. That's significantly higher than other whales. High enough that scientists believe other whales simply can't hear it. Or if they can hear it, they don't recognize it as whale song. It's the wrong frequency, the wrong pitch. Like trying to tune into a radio station, but being just slightly off the frequency. All you get is static and garbled noise, not the clear signal you're looking for. So this whale swims through the Pacific, singing its song, calling out the way whales do, trying to communicate, trying to find others, trying to connect. And no one answers. No one responds. Because no one can hear it properly. Researchers have been tracking this whale for over 30 years now. They recognize its unique call signature, its unusual frequency. They've plotted its migrations. It travels the same routes that other whales travel, moving with the seasons, following food sources. It's doing everything a normal whale does. Except it's doing it alone. Always alone. The recordings of the 52 Hz whale's song are haunting to listen to. Even when the frequency is shifted so humans can hear it properly, there's something plaintive about it. Something melancholic. A voice calling out into emptiness, over and over, year after year, receiving no reply. Scientists don't know exactly what type of whale it is. The frequency is wrong for any known species. It might be a hybrid, the offspring of two different whale species, inheriting vocal characteristics that don't quite match either parent. Or it might be a whale with some kind of physical abnormality that affects how it produces sound. Or it might be something else entirely, a rare variation, a mutation, something unique. Whatever the reason, the result is the same. This whale is functionally isolated, cut off from others of its kind not by distance or physical barriers, but by frequency, by the simple fact that it speaks a language no one else understands. When the story of the 52 Hz whale first became widely known, it captured public imagination immediately. People were deeply moved by the idea of this lonely creature, swimming through the vast ocean, calling and calling, but never being heard. Documentary filmmakers tried to find it. Musicians wrote songs about it. It became a metaphor for human loneliness, for the experience of feeling isolated even when surrounded by others, of speaking and not being heard, of reaching out and receiving no response. But here's something interesting. Some scientists have questioned whether the 52 Hz whale is actually lonely. Does it even know it's alone? Does it understand that no one is responding to its calls? Does it feel loneliness the way humans do? We don't know. We can't know. We're projecting human emotions onto a whale, which may or may not be appropriate. The whale might be perfectly content, perfectly fine, living its life without distress or sadness. Loneliness might be a human interpretation of a situation that the whale itself doesn't perceive as problematic. Or maybe it does feel lonely. Maybe whales do experience something like loneliness when they're isolated from others. We know whales are intelligent, social creatures. We know they form bonds, communicate in complex ways, coordinate their behaviors. It's not unreasonable to think they might feel something when those social connections are absent. But we simply don't know. And perhaps that's part of what makes the story so powerful. The uncertainty. The fact that we're looking at this situation from the outside, imagining what it must be like, projecting our own fears and experiences onto this whale swimming somewhere in the vast Pacific. Because haven't we all felt like the 52 Hz whale at some point? Haven't we all had times when we felt like we were calling out and no one was listening? When we were speaking but not being heard? When we were reaching out but receiving no response? Maybe we were speaking the wrong frequency for the people around us. Maybe our way of communicating, our way of expressing ourselves, just didn't match up with what others could receive or understand. Not because there's something wrong with us, and not because there's something wrong with them, just a mismatch. Just a frequency difference. It's one of the most painful experiences of being human. Feeling isolated even when you're surrounded by people. Feeling like you're speaking a language no one else understands. Feeling like you're calling out into the void and hearing only silence in return. The 52 Hz whale swims on, year after year, singing its unique song. And maybe it's lonely, or maybe it's not. Maybe it's learned to be content with its own company. Maybe it's found peace in solitude. Or maybe it's still hoping that someday, somewhere, another voice will answer from the deep. We don't know what the future holds for this whale. It's been alive for at least 35 years. Probably longer, since it was already adult-sized when first detected. Whales can live for many decades, some species for over a century. So the 52 Hz whale might swim and sing for many more years yet. And scientists will keep listening, keep tracking, keep recording that unique 52 Hz call as it moves through the Pacific. Not because they can help it. There's nothing they can do to change its frequency or connect it with other whales. Just because they want to bear witness, to acknowledge that this whale exists, to hear its call, even if no other whale can. And maybe that's enough. Maybe being heard, even by a different species, even by humans with their hydrophones and their tracking equipment. Maybe that counts for something. Maybe the whale isn't as alone as we think, because we're listening. We're paying attention. We're bearing witness to its existence. Fact 24. The Arong Medon. Now let's turn to something darker. Something that exists at the boundary between fact and legend, between documented history and maritime myth. It's a story about a ghost ship. A vessel found drifting in the waters between Indonesia and Malaysia in 1948. Its entire crew dead in circumstances so bizarre, so disturbing, that the story has haunted maritime lore ever since. The ship was called the Arong Medon, which translates roughly to Man from Medan, a reference to the Indonesian city of Medan. According to the story, and we should note that details vary and documentation is sparse, in June 1947, or possibly early 1948, multiple ships in the Strait of Malacca received a distress call. The message was in Morse code, and it was chilling. All officers, including captain, are dead lying in chart room and bridge. Possibly whole crew dead. Then, after a pause, another message. I die. And then silence. The transmission ended. 2 American vessels in the area picked up the distress signal and were able to triangulate the approximate location. The Silver Star, an American merchant ship, was the closest and changed course to investigate. When they reached the coordinates, they found the Arong Medon drifting aimlessly in the water. The ship appeared intact, no visible damage, no signs of fire or collision or storm damage. But there was no response to their hails. No sign of life aboard. The Silver Star crew approached carefully and sent a boarding party across to investigate. What they found, according to the reports, was deeply disturbing. The entire crew was dead. Every single person aboard. But they hadn't died in a fire or a shipwreck or any normal maritime disaster. They were simply dead, lying where they had fallen, scattered throughout the ship. And the manner of their death was what made the story truly horrifying. According to the accounts, the bodies were found with their eyes wide open, staring. Their faces were frozen in expressions of terror, as if they had seen something so frightening in their final moments that the fear was permanently etched into their features. Some bodies had their arms outstretched, reaching towards something, or perhaps trying to ward something off. Even the ship's dog was found dead, its face frozen in a snarl, as if it had been growling at something unseen in its final moments. The boarding party from the Silver Star reported feeling deeply unsettled by the scene. The air felt wrong somehow. Oppressive. Some crew members reported feeling nauseous or dizzy while aboard the Arong Medon, though there was no obvious source of toxic gas or any other hazard. The captain of the Silver Star made the decision to tow the Arong Medon back to port so authorities could investigate. A tow line was attached, and they began the slow journey. But before they could reach port, something happened. Smoke was seen coming from the Arong Medon's hull. The smoke quickly intensified. The Silver Star crew quickly cut the tow line and moved away. And then the Arong Medon exploded. A massive explosion tore through the ship, and it sank rapidly, disappearing beneath the waves within minutes, taking all evidence, and all bodies, down with it into the deep. That's the story as it's usually told. And if it's true, it's one of the most mysterious maritime disasters on record. An entire crew dead from no apparent cause, their faces frozen in terror, their bodies reaching toward or away from something unseen. And then the ship itself exploding and sinking before anyone could properly investigate. But here's the problem: documentation is scarce. Very scarce. There are references to the Arong Medon incident in various maritime publications and newspapers from the late 1940s and early 1950s. But there's no official record of the ship itself. No registration. No manifest. No documentation of its cargo or destination. Some researchers have suggested the Arong Medon might have been involved in smuggling, possibly transporting illegal or dangerous cargo. Perhaps chemical weapons left over from World War II, which had ended just a few years earlier. Maybe the cargo leaked, creating toxic fumes that killed the crew. That would explain the sudden deaths, and possibly the explosion afterward if the cargo was volatile. Others have suggested the entire story might be a hoax or an embellishment of some other, less dramatic incident. A real ship disaster that got exaggerated in the retelling, details added, and changed until it became the story we know today. The truth is, we don't know. The Arong Medon, if it existed as described, is at the bottom of the ocean now, along with all evidence of what happened aboard it. The story exists in that liminal space between history and legend, between documented fact and maritime folklore. But true or not, the story resonates, because it touches on deep fears we all have. The fear of dying suddenly, without warning, without explanation. The fear of encountering something so terrifying that it literally freezes your face in an expression of horror. The fear of ships drifting empty in the ocean, carrying only the dead, silent witnesses to some unknown tragedy. The ocean is full of these stories. Ghost ships found drifting with no crew aboard. The Mary Celeste, found in 1872 with the crew simply vanished, their breakfast still on the table. No sign of struggle or disaster. The Carol A. Deering, found run aground in 1921, all crew missing. No explanation ever found. There's something deeply unsettling about the idea of a ship without its crew. A vessel that should be full of human activity. People working, talking, living. Instead empty and silent, drifting through the water like a floating tomb. The Arong Medon story takes that fear and amplifies it. Not just an empty ship, but a ship full of the dead. Not just bodies, but bodies frozen in terror, reaching towards something, staring at something we can't see and will never understand. Whether the story is literally true or not almost doesn't matter. It's true in the way that myths are true. It represents something real about our relationship with the ocean. Our fear of it, our inability to control it or fully understand it. The way it can swallow ships and crews and evidence, keeping its secrets forever in the deep. Fact 25. The Baltic Sea Anomaly. Let's talk about something strange at the bottom of the Baltic Sea. Something that was discovered in 2011 by a Swedish treasure hunting team and has puzzled people ever since. The team was using side-scan sonar to search the seafloor, looking for shipwrecks and valuable cargo. Side-scan sonar creates images of the seafloor using sound waves, allowing you to see what's down there without actually diving. And their sonar picked up something unusual. Very unusual. At a depth of about 300 feet, on the seafloor between Sweden and Finland, there was an object. A large circular object, roughly 200 feet in diameter. And the shape was striking. It looked almost artificial, almost engineered. The sonar image showed what appeared to be a disc or a dome, with geometric features, angular edges, channels or grooves cut into its surface. Some people looked at the sonar image and immediately thought, that looks like a UFO. like a flying saucer, like something out of science fiction, sitting on the bottom of the Baltic Sea. The media picked up the story and ran with it. The Baltic Sea anomaly, they called it. Was it an alien spacecraft that had crashed into the Baltic Sea thousands of years ago? Was it some kind of ancient structure built by an unknown civilization? Was it evidence of something beyond our current understanding of history and technology? The treasure hunting team was intrigued enough to organize diving expeditions to examine the object directly. And this is where things got even stranger. According to the divers, something odd happened when they approached the anomaly. Their electronic equipment started malfunctioning. Cameras stopped working. Sonar equipment shut down. Satellite phones lost connection. Only when they moved away from the object, beyond about 600 feet from it, did their equipment start working normally again. This claim added fuel to the speculation. What could cause electronic equipment to malfunction in a specific radius around an object? Some kind of electromagnetic field? Some kind of unknown technology? Was the object still active, still powered, still emitting some kind of energy after sitting on the seafloor for who knows how long? The divers managed to collect some samples from the object's surface and brought them back for analysis. And the samples showed, well, it depends on who you ask. Some geologists who examined the samples said they were consistent with natural rock formations. Basalt and other volcanic rocks that could be formed by natural geological processes. Nothing unusual. Nothing that required artificial origin or alien technology to explain. But the treasure hunters and their supporters argued that the shape was too regular, too geometric to be entirely natural. That the channels and grooves looked like they had been cut or carved. That natural processes don't create 200-foot circles with such defined edges. So where does that leave us? What is the Baltic Sea anomaly? The most likely explanation, according to mainstream scientists, is that it's a natural geological formation, possibly a glacial deposit, a large chunk of rock that was moved and shaped by glaciers during the last ice age, then left on the seafloor when the ice melted. The Baltic Sea region was heavily glaciated, and glaciers can create unusual rock formations, sometimes with surprisingly regular shapes and features. The circular shape could be explained by the way the rock formation fractured or eroded. The grooves could be natural channels carved by water or ice. The whole thing could be a perfectly natural phenomenon that just happens to look unusual when seen on sonar. As for the claims about electronic equipment malfunctioning, well, that's harder to verify. The treasure hunting team made these claims, but there's no independent confirmation. No other research teams have reported similar experiences. It's possible the equipment failures were just coincidental. Electronics do malfunction sometimes, especially in the harsh conditions of deep water diving. Salt water, cold temperatures, pressure, all of these can cause equipment problems. Or maybe the equipment failures were exaggerated or misremembered. Human memory is fallible, especially when we're primed to expect something unusual. But let's say, for the sake of imagination, that the Baltic Sea anomaly really is something unusual. Something we don't fully understand. What would that mean? If it's artificial, if it really is some kind of structure or craft, then who built it or piloted it? If it's ancient, it would predate any known civilization in the region. If it's modern, why would it be sitting on the seafloor with no one claiming it or investigating it properly? The alien spacecraft theory is exciting, but requires a lot of assumptions. Not just that aliens exist, but that they visited Earth, that their craft crashed in the Baltic Sea specifically, that it's still intact after potentially thousands of years, that it's generating electromagnetic fields strong enough to disrupt modern electronics, but not strong enough to be detected by other means. It's possible, technically, but it requires so many unlikely things to all be true that it's not the most parsimonious explanation. The truth is probably more mundane. Probably a natural rock formation that looks unusual. Probably some equipment glitches that got exaggerated in the retelling. Probably nothing more mysterious than geology and human tendency to find patterns and meaning in ambiguous shapes. But here's what's interesting. We want it to be mysterious. We want the Baltic Sea anomaly to be something strange and unexplained. Because in a world where so much has been mapped and measured and understood, we still crave mystery. We still want to believe there are unknowns out there, things that don't fit into our neat categories and explanations. The Baltic Sea anomaly, whatever it is, gives us that. It gives us permission to wonder, to speculate, to imagine possibilities beyond the everyday. Even if the final answer is, it's just rocks, the journey of wondering is valuable in itself. And maybe that's okay. Maybe we don't need to definitively solve every mystery. Maybe some things can remain in that liminal space of uncertainty, where they could be natural or could be something else, where imagination and reality blur together. The Baltic Sea anomaly sits there still, 300 feet down, on the seafloor between Sweden and Finland. Diverse can visit it if they want. It's not a secret. It's not hidden. But it remains, at least partly, a mystery. And maybe that's exactly how it should be. Fact 26. The Dragon's Triangle. We'll end this set with one more mystery. One more area of ocean that has earned a reputation for danger, for disappearances, for unexplained phenomena that challenge easy explanation. Most people have heard of the Bermuda Triangle, that region of the Atlantic Ocean between Florida, Bermuda, and Puerto Rico, where ships and planes have supposedly disappeared under mysterious circumstances. It's become famous, almost legendary, a staple of mystery shows and conspiracy theories. But fewer people know about the Dragon's Triangle. It's located off the coast of Japan, roughly stretching from the southern tip of Japan's southeast toward the Bonin Islands and Guam. It's sometimes called the Devil's Sea or the Dragon's Triangle, and according to Japanese legend and more recent maritime history, it's even more dangerous than the Bermuda Triangle. The waters in this region have been considered dangerous for centuries. Ancient Japanese sailors told stories about dragons living in these waters, enormous serpents that would pull ships down into the depths. Hence the name, the Dragon's Triangle, a place where dragons lurked, waiting to devour vessels. But it's not just ancient legend. There are modern reports too, documented cases of ships disappearing in this region. And some of these disappearances are genuinely mysterious. In the early 1950s, Japan apparently lost several fishing vessels in these waters. Different accounts give different numbers. Some say 5 ships, some say 9 or more. The ships simply vanished. No wreckage found. No survivors. No distress calls received. The Japanese government became concerned enough that they sent a research vessel to investigate. The Ko Maru No. 5, a ship specifically designed for oceanographic research, was dispatched to study the area and try to understand why so many vessels were disappearing. And then the Ko Maru No. 5 itself disappeared. The research vessel, with its crew of scientists and sailors, vanished in the Dragon's Triangle. No wreckage, no survivors, no explanation. After this, the Japanese government reportedly declared the area a danger zone and advised ships to avoid it when possible. So what's going on in the Dragon's Triangle? Why would so many ships disappear in this particular region? There are several possible explanations, and the truth probably involves a combination of factors. First, the region is geologically active. It sits along the Pacific Ring of Fire, a major area of seismic and volcanic activity. There are several underwater volcanoes in the area, including some that are active. Underwater volcanic eruptions can be extremely dangerous to ships. They can create sudden waves, emit toxic gases, cause localized disturbances in the water that could damage or sink vessels. In fact, some researchers believe the Ko Maru No. 5 might have been caught in an underwater volcanic eruption. The ship disappeared suddenly, with no distress call, which would be consistent with a catastrophic event like a submarine eruption happening directly beneath the vessel. Second, the Dragon's Triangle experiences severe weather. It's in the path of typhoons that sweep across the Pacific. These storms can be incredibly violent, with waves tall enough to overwhelm even large ships. And in the 1950s, weather forecasting wasn't as advanced as it is today. Ships might have sailed into storms without adequate warning, been caught in conditions they couldn't survive. Third, the region has strong and unpredictable currents. Ocean currents in this area can change rapidly, and they can interact in complex ways that create hazardous conditions. Combine strong currents with bad weather, and you have a recipe for maritime disasters. Fourth, and this is more speculative, some people point to the possibility of rogue waves. These are enormous waves, sometimes 60, 80, even 100 feet tall, that appear suddenly in open ocean, seemingly out of nowhere. They're not tsunami waves caused by earthquakes. They're just statistical anomalies in wave patterns, places where multiple wave sets happen to converge and create one massive wave. Rogue waves are rare, but they do occur, and they can destroy ships that encounter them. A rogue wave appearing suddenly in rough seas, hitting a ship broadside, that could sink a vessel in minutes, with no time for a distress call, no survivors, no wreckage that stays afloat long enough to be found. So there are natural explanations for why the Dragon's Triangle might be dangerous. Volcanic activity, severe weather, strong currents, possibly rogue waves. Combine these factors, and you have an area of ocean that's legitimately hazardous, especially for smaller vessels or ships caught in bad conditions. But still, the mystery persists. Because even accounting for natural hazards, some of the disappearances seem difficult to explain. Ships vanishing without any distress call, no wreckage ever found, in conditions that weren't obviously dangerous at the time. Is the Dragon's Triangle cursed? Haunted by ancient dragons or malevolent spirits? Almost certainly not. Is it dangerous? Yes, genuinely dangerous, for natural reasons. Is it more dangerous than other areas of ocean? That's harder to say. The statistics are murky, records are incomplete, especially for historical periods. It's possible the Dragon's Triangle has been given an exaggerated reputation, that it's actually no more dangerous than many other areas of ocean, once you account for the volume of maritime traffic. But perception matters. Reputation matters. And the Dragon's Triangle has a reputation. Sailors know about it. Captains take it into account when plotting courses. It exists in the cultural consciousness as a place of danger, a place where ships disappear, a place to be avoided, or at least treated with extreme caution. And maybe that's appropriate. Maybe it's a reminder that the ocean, for all our technology and all our knowledge, is still dangerous. Still capable of swallowing ships and planes and people. Still holding mysteries in its depths. We like to think we've conquered the ocean, that we understand it, that we can predict and control it. But stories like the Dragon's Triangle remind us that we haven't. Not really. The ocean is still wild, still powerful, still capable of surprising us, challenging us, defeating us. And maybe that's how it should be. Maybe we shouldn't conquer the ocean. Maybe we should respect it, treat it with caution, acknowledge its power and its mystery. Fact 27. The Antikythera mechanism. Let's talk about something that shouldn't exist. Something that challenges what we think we know about ancient history, about technology, about human capability thousands of years ago. In 1901, a group of Greek sponge divers were working off the coast of the island of Antikythera, between mainland Greece and Crete. They were diving deep, searching for sponges, when they stumbled upon something unexpected. A shipwreck. An ancient shipwreck, lying on the seafloor at about 150 feet deep. The wreck was old, very old, dating back to somewhere around 70 to 60 BCE, over 2,000 years ago, and it was full of treasures. Bronze statues, marble sculptures, pottery, glassware, jewelry. It was like discovering a time capsule from ancient Greece, a snapshot of art and culture from 2 millennia ago. The Greek government organized a proper archaeological expedition to recover artifacts from the wreck. And among the statues and pottery, among the obvious treasures, they found something strange. A lump of corroded bronze and wood, encrusted with limestone and shellfish, barely recognizable as anything manufactured. At first, they almost overlooked it. It looked like just another piece of debris, another bit of corroded metal. But when it dried out and split apart, they saw something inside. Gears. Bronze gears, intricate and carefully crafted, meshed together in complex arrangements. It took decades of study, and it's still being studied today. But slowly, scientists and historians began to understand what they were looking at. It's called the Antikythera mechanism now, named after the island near where it was found. And it's an analog computer, a mechanical device designed to calculate and predict astronomical phenomena, the positions of the sun and moon, the phases of the moon, lunar and solar eclipses, possibly even the positions of planets. The mechanism consists of at least 30 bronze gears, possibly more, as parts are missing, arranged in a wooden case about the size of a shoebox. On the outside were dials and pointers. The user would turn a crank, and the gears would rotate at different rates, moving the pointers to show astronomical information for any date you wanted. It's sophisticated, incredibly sophisticated. The gear work is precise, with teeth carefully cut to specific shapes to ensure accurate meshing. The astronomical calculations it performs are complex, accounting for the irregular motion of the moon, the varying lengths of months, the cycles of eclipses. And here's the really stunning part. Nothing else like this exists in the historical record for another 1,000 years. The next mechanical devices of comparable complexity don't appear until medieval clockwork in Europe, around 1000 to 1400 CE. That's a gap of over a millennium. It's as if someone in ancient Greece had built a laptop computer, and then humanity forgot how to make computers for 1,000 years, and when we finally reinvented them, we had no memory of the earlier device. How is this possible? How could ancient Greeks build something this sophisticated, and then have the technology apparently disappear for centuries? The answer probably lies in the fragility of knowledge transmission in the ancient world. Knowledge wasn't written in books that could be mass-produced and distributed. It was held by individuals, by craftsmen and scholars, passed down through apprenticeships and oral tradition. If the person or people who knew how to build devices like the Antikythera mechanism died without successfully passing on their knowledge, maybe in war or plague, or simply because they had no suitable students, that knowledge could be lost, completely lost, for centuries. The Antikythera mechanism suggests that ancient Greek technology was far more advanced than we typically imagine. We think of ancient Greeks as having philosophy, art, mathematics, early science. But mechanical engineering of this sophistication? Most people don't associate that with ancient civilizations. And yet here it is. Physical proof. You can see it in museums. You can see the X-ray scans that show the gears inside. You can see the reconstructions that demonstrate how it worked. It's not speculation or legend. It's real. What else did the ancient world have that we've lost or forgotten? What other technologies existed that left no trace, or only traces so fragmentary we don't recognize them? The Antikythera mechanism was only preserved because it happened to be on a ship that sank, and the ocean preserved it in an environment where it could survive for 2,000 years. How many other devices like this were built, used for decades or centuries, and then eventually corroded away to nothing, leaving no evidence they ever existed? We'll never know. We can only speculate. But the Antikythera mechanism stands as a reminder that history is more complex than we often assume. That ancient peoples were capable of sophisticated thinking and engineering that rivals or exceeds what came after. That knowledge and technology don't progress in a straight line. Sometimes they advance, and sometimes they're lost, and sometimes they have to be reinvented from scratch. It's humbling, in a way. We like to think of ourselves as the pinnacle of human achievement. The most advanced, the most knowledgeable, the most capable humans who have ever lived. And in many ways, that's true. We have technologies the ancient world couldn't have dreamed of. But the Antikythera mechanism reminds us that brilliance isn't unique to our age. That 2,000 years ago, someone, or a group of someones, was brilliant enough to design and build a mechanical computer using bronze gears and ancient mathematics. That human ingenuity and capability have always been present, just sometimes expressed in different forms. And it reminds us that preservation of knowledge matters. That what we know can be lost if we're not careful. That libraries and books and digital storage and education systems aren't just conveniences. They're essential safeguards against losing everything we've learned. Fact 28. Underwater cemeteries. Let's talk about something that exists at the intersection of the beautiful and the macabre. Something that's both peaceful and unsettling, depending on how you look at it. Off the coast of Florida, about 3.5 miles from Key Biscayne, at a depth of about 40 feet, there's a cemetery. Not on land, but underwater. A city of the dead on the ocean floor. It's called the Neptune Memorial Reef, and it's unlike any cemetery you've ever seen. Picture this: an underwater landscape of columns and archways, statues of lions and sea creatures, gates and benches and memorial plaques. All made of concrete, all resting on the sandy seafloor, all covered in algae and coral, and surrounded by schools of tropical fish. It looks like the ruins of some ancient civilization, a lost city that sank beneath the waves centuries ago. But it's not ancient. It's modern. Very modern. Construction began in 2007, and it's still being expanded. And it's not just decorative. The structures contain human remains. Here's how it works. People who choose to be memorialized at the Neptune Memorial Reef are cremated after death. Their ashes are then mixed with concrete and molded into shapes: lions, columns, plaques, architectural elements. The concrete mixture becomes part of the reef structure itself, permanently incorporated into this underwater memorial. Each element, each piece of the structure, contains someone's cremated remains. The lion statues, those contain people. The columns, those contain people. The memorial plaques embedded in the structures, those mark where specific individuals are incorporated into the reef. It's a literal city of the dead, an underwater necropolis. Except unlike traditional cemeteries on land, this one is designed to support life. The concrete provides substrate for coral to grow. The structures create habitat for fish and other marine life. The cemetery becomes a reef, teeming with living creatures, even as it serves as a final resting place for the dead. There's something poetic about that, isn't there? Death supporting life. Human remains becoming part of a structure that nurtures coral and provides shelter for fish. The cycle of life and death made visible and tangible in a unique way. But there's also something unsettling about it. The idea of swimming through a cemetery, of seeing statues of lions on the seafloor, and knowing they contain the cremated remains of actual people, of touching a column or a plaque and realizing you're touching someone's final resting place. Divers visit the Neptune Memorial Reef regularly. It's become a dive site, a tourist attraction of sorts. People come to see the underwater sculptures, to photograph the fish that have made homes in the structures, to experience the strange beauty of this underwater city. And some come to visit loved ones. Family members of people memorialized at the reef can dive down to see and touch the structures that contain their loved ones' remains. They can leave flowers, weighted down so they don't float away, or other mementos. They can spend time in this underwater space with the memory of someone they've lost. It's a different kind of cemetery experience than visiting a traditional graveyard on land. You can't just walk up to a grave whenever you want. You need scuba certification, or you need to hire a dive operator. You have to wait for good weather and clear water. You have to descend 40 feet, breathing compressed air, equalizing pressure in your ears, entering a completely different environment. But proponents of the Neptune Memorial Reef say that's part of the appeal. It's special. It's unique. It's not just another cemetery with rows of identical headstones. It's a vibrant, living place where death and life coexist in a very literal way. The Neptune Memorial Reef isn't the only underwater cemetery. There are others around the world, though few are as elaborate. Some are simple memorial plaques attached to reefs. Some are concrete structures designed as artificial reefs that also serve as memorials. The concept is growing in popularity, especially among people who loved the ocean, who spent their lives diving or sailing, or simply enjoying the sea. There's a certain logic to it. If you spent your life connected to the ocean, why not spend your death there too? Why not become part of the marine ecosystem? Quite literally, your remains contributing to reef growth and marine habitat. But still, there's that undercurrent of unsettlement. The idea of bodies, even cremated, processed, mixed with concrete, resting on the seafloor. The image of divers swimming past memorials, through archways that are also tombs, around statues that contain human remains. It challenges our usual separation between the living and the dead, between spaces for life and spaces for death. In traditional cemeteries, the boundary is clear. The dead are buried or entombed, and we visit them, but we don't live there. We don't have picnics or play sports in cemeteries, or at least, we're not supposed to. But at the Neptune Memorial Reef, fish swim through the memorial structures. Coral grows on them. Octopuses might make homes in the crevices. Sea turtles might rest on the lion statues. Life happens there, all around and among the remains of the dead. Maybe that's how it should be. Maybe death shouldn't be separated so completely from life. Maybe the dead should be part of the living world, part of the cycle, part of the ongoing story of existence, rather than sealed away in boxes underground. Different cultures have different relationships with death and the dead. Some cultures keep the dead close, in homes, in daily rituals, in constant remembrance. Others prefer distance. The dead buried far from where people live, visited occasionally, but mostly kept separate. The Neptune Memorial Reef represents a new approach, or perhaps a revival of older approaches in a new form. The dead as part of nature, death as a transition that feeds back into life, rather than an ending that must be sealed away. Fact 29. The sound of the abyss. We've talked a lot about darkness in the deep ocean, about the eternal midnight that exists at depth, where no light penetrates, where creatures live their entire lives without ever seeing the sun. But we haven't talked much about sound, about what the deep ocean sounds like. Because most people, when they imagine the deep ocean, imagine silence. A vast, quiet void where nothing makes noise because there's nothing there to hear it. But that's not true. The deep ocean isn't silent. Not at all. In fact, if you could somehow sit at the bottom of the Mariana Trench, protected from the crushing pressure, sitting in the darkness with a good microphone, you'd hear an astonishing variety of sounds. First, you'd hear the Earth itself, the low-frequency rumble and groan of the planet's crust shifting. The ocean floor isn't static. It's constantly moving, very slowly, as tectonic plates shift and grind against each other. This movement creates sounds. Deep, low sounds, often below the threshold of human hearing without amplification, but they're there. A constant bass note, the voice of the Earth itself, humming and groaning in the depths. Then you'd hear the sounds of marine life. Whales, even though they might be miles away, swimming in shallower waters far above you. Whale songs travel incredible distances through water. A whale singing off the coast of California might be heard by another whale near Hawaii, hundreds of miles away. Sound travels far in the ocean, much farther than in air, and it travels especially well at certain depths where water temperature and pressure create acoustic channels that focus and carry sound waves efficiently. So sitting in the abyss, you'd hear whales. But they wouldn't sound quite right. The distance and the layers of water they've traveled through would distort them. They'd be warped, strange, almost alien-sounding. Still recognizable as whale song, maybe, but filtered and changed by their journey through the deep. Haunting voices from far away, calling across the darkness. You'd hear the sounds of smaller creatures too. Snapping shrimp, creating their sharp, cracking sounds. These shrimp are actually one of the loudest animals in the ocean relative to their size. They snap their claws shut so fast that it creates a cavitation bubble, which collapses with a surprisingly loud pop. In shallow waters, the collective sound of snapping shrimp can be deafening. Even in the deep, you'd hear them, though fewer and more scattered. You'd hear fish. Many species of fish produce sounds, grunts, croaks, hums, clicks. They use these sounds to communicate, to attract mates, to establish territory. Even in the deep, where food is scarce and life is sparse, fish make sounds. Quiet sounds, usually, but sounds nonetheless. You'd hear ice. If you were in polar waters, you'd hear the cracking and groaning of icebergs calving, of ice sheets shifting. Remember the bloop? That was ice, creating a sound loud enough to be heard across thousands of miles. Even smaller ice events create sounds that propagate through the ocean, adding to the acoustic environment of the deep. You'd hear weather. Storms on the surface create sounds that penetrate to the depths. Wind creating waves, waves breaking, rain hitting the surface. All of these create acoustic energy that travels downward. A major storm can actually be quite loud underwater, the surface chaos creating a roar that reaches even the deepest parts of the ocean. And you'd hear human activity. Ships passing overhead, even if they're miles above you. Ship engines and propellers create low-frequency sounds that travel deep. Submarines, obviously. Sonar pings from naval vessels and research ships. Underwater construction, mining, oil drilling. Seismic surveys for oil exploration, which use air guns that create incredibly loud pulses of sound, so loud they can be detected across entire ocean basins. Humanity has made the ocean much louder than it used to be. Background noise levels in the ocean have increased dramatically over the past century as maritime traffic has increased. This is a problem for marine life, especially whales and dolphins that rely on sound for communication and navigation. It's like trying to have a conversation in a noisy bar. Possible, but difficult, and you might miss important information. So the deep ocean isn't silent. It's full of sounds, full of voices. The earth groaning, whales singing, creatures clicking and snapping, ice cracking, storms roaring, ships rumbling. It's a soundscape, a symphony of sorts, though not a particularly harmonious one. And most of these sounds are low frequency. Bass notes, rumbles and drones and moans. High-frequency sounds don't travel well in water, they get absorbed quickly. But low frequencies can travel hundreds or thousands of miles, creating a constant low-frequency background hum in the deep ocean. If you could hear it properly, it might be overwhelming, like standing next to a massive subwoofer at a concert, feeling the bass in your chest and bones as much as hearing it with your ears. The deep ocean is full of that kind of sound, vibrations that you'd feel as much as hear. There's something primordial about low-frequency sound. It resonates with us at a deep level, maybe because our bodies respond to it physically, not just through our ears. Low frequencies can make us feel uneasy, anxious, even frightened, without us quite knowing why. Horror movies use low-frequency sounds to create tension and dread. The feeling that something is wrong, something is coming, even when we can't see or identify the threat. The deep ocean is full of that feeling, full of low-frequency dread, if you want to think of it that way. The groaning of the earth, the distorted moans of distant whales, the rumble of ships and seismic surveys. It's not a peaceful soundscape, not exactly. It's powerful, primal, the sound of forces beyond human scale, beyond human control. But it's also, in its way, beautiful. The earth singing its deep song, whales calling across vast distances, maintaining connections across empty water. Life persisting, communicating, continuing, even in the darkest, most extreme places. Fact 30. We are not alone. Let's end with a thought that's both comforting and unsettling. A reminder of how much we don't know, how much remains to be discovered, how much mystery still exists in our world. Scientists estimate that there may be up to 1 million species living in the deep ocean that we have not yet discovered. 1 million. That's not a small number. That's not a rounding error. That's an entire hidden biosphere, a shadow ecosystem existing alongside the species we know about, completely undocumented, completely unknown to science. Think about all the strange creatures we've talked about tonight. The goblin shark with its slingshot jaws, the anglerfish with its parasitic males, the giant isopods and the vampire squid and the zombie worms. All of these bizarre, alien-seeming creatures that push the boundaries of what we think life can be. And those are the ones we know about. Those are the ones we've discovered, documented, studied, photographed. Those are the ones that have been caught in nets or seen by submersibles or washed up on beaches. Those are the species we've managed to find despite the vastness of the ocean and the difficulty of exploring the deep. But if scientists are right, if there really are 1 million undiscovered species in the deep, then everything we know is just a fraction. Just a tiny sample. The tip of the iceberg. Which means the creatures we've discovered, as strange and bizarre as they are probably among the most normal ones down there. Think about that. The goblin shark with its extending jaws? Probably relatively ordinary compared to what we haven't found yet. The anglerfish, with its horrifying reproductive strategy, probably pretty standard as deep-sea creatures go. The really strange ones, the truly alien ones, the creatures that would absolutely blow our minds and challenge everything we think we know about biology. Those are still down there undiscovered, living their lives in the darkness, completely unknown to us. What might they look like? What bizarre adaptations might they have? What strange life cycles? What unusual hunting strategies? What completely unexpected ways of surviving in the extreme environment of the deep ocean? We can't even imagine, because our imagination is limited by what we've already seen, what we already know. We can extrapolate, we can speculate, but we can't truly envision something completely novel, something outside our experience. The ocean is full of those things, full of creatures that would seem impossible if we described them before discovering them. If you told someone who had never seen an anglerfish that there's a fish where the male bites into the female and fuses with her body, becoming a permanent parasitic sperm producer, they'd say you were making it up. That's too weird. That's too bizarre. That can't be real. But it is real. And there are probably things down there even weirder, even more impossible seeming, even more alien. Maybe there are creatures that live for centuries, barely moving, barely metabolizing, existing in a state that's barely distinguishable from death, but technically still life. Maybe there are creatures that can reassemble themselves after being torn apart, like something from a science fiction movie. Maybe there are creatures that exist partly in one form and partly in another, blurring the line between different kingdoms of life. Maybe there are things down there that don't fit into our categories at all. Things that are neither plant nor animal, neither bacteria nor fungus, but something else entirely. Something we don't have words for yet, because we haven't discovered it. The ocean is full of possibilities, full of life we haven't encountered, full of mysteries we haven't solved. And in a way, that's wonderful. In an age where it can feel like everything has been discovered, everything has been documented, everything has been posted on the internet, it's remarkable to know that there's still so much unknown, so much unexplored, so much waiting to be found. We haven't exhausted the world's capacity to surprise us. We haven't learned everything there is to learn. We haven't seen everything there is to see. The deep ocean, with its estimated million undiscovered species, is a reminder of that. A reminder that mystery still exists, that the unknown is still vast, that we're still explorers on a planet full of wonders. And maybe that's how it should be. Maybe we shouldn't know everything. Maybe there should always be frontiers, always be unknowns, always be discoveries waiting to be made. It keeps us humble, keeps us curious, keeps us wondering and searching and exploring rather than assuming we've figured it all out.